Hi, I'm Adi Arun, and I have created a course where you'll be taken through the perplexing algorithmic journey of creating a complex 2D version of the game Minecraft with Flutter and a bare bones game engine package Flame. This is a jam packed, all in one 24-hour long course made with 600 hours of dedicated work, which will leave you well on your way to becoming a better developer. In this course, we'll cover every prominent feature that makes Minecraft the game it is, including procedural terrain generation with Perlin noise, biome generation for deserts and birch forests. This is of course expandable. Structure generation for trees, cacti, flowers, etc. Chunk rendering and unrendering logic. Dynamic crafting algorithms. An intensive inventory storage algorithm mirrored on a versatile inventory UI, day-night time cycle paired with the Parallax Sky, hostile mobs including zombies, spiders with their own AI, a large arsenal of tools and weapons with specific functionality, gravity blocks like sand, world saving with Hive, an interactive launcher for creating worlds, and much more. All of these complex features and code are packed and explained line by line with captivating animations. But this is not it. You can expand on my take to Minecraft, as this course was designed to encourage your creativity. If you have any problems while coding, you can reach out to me on my Discord server. Now let's work on throwing items out of our inventory. To do this, we'll create drag targets at the left and right side of our inventory. And when a draggable feedback is placed on it, it's going to create count number of that block item components into our world. And if I throw this out to the left, it's going to create that item component there. And if to the right, it's going to create it to the right. Rather than adding the drag targets to the player inventory, let's add it to the inventory storage widget, so that in the future when we create new widgets such as this that implement the inventory storage widget, we'll also get the item dropping functions there. So let's go inside inventory storage widget by holding control and then clicking on it. And let's actually wrap this entire thing around a row. So we'll create a row with two widgets in the left and right, which will be our drag targets, which occupy all the space it possibly can. We'll do that with the help of the expanded widget. And we'll have the, main inventory widget, which is everything under our padding, as the widget in the middle. So let's say drag target here. And let's copy this. And drag target here. So in the left and right. So let's actually create a function that returns our drag target. Widget get drag target. And actually, let's not create our drag target right now. For now, let's just return a container with the color as colors dot amber, right? And let's wrap this container around an expanded widget. Now, everywhere we have drag target here, we'll do get drag target. And here too, get drag target. Let's hot restart our game. Now let's open our inventory. And we get something. Okay, let's first remove, let's go into a inventory storage widget again. And then remove the gray container that we actually just created as a placeholder for the crafting UI slot. So let's search up for gray, GREY. And it seems to not be here. Alright, that's actually inside the play inventory. So let's cut this out entirely. We'll implement that later. Let's restart our game again. Open the inventory. And yes. So we have our container, our amber colored container, both in the left and right, occupying all the space that it possibly can. That is because of the implementation of our expanded widget. So that basically, you can use an expanded widget inside a row or a column or a flex, and then it'll basically just take up all the space it can, right? So that's how our constraints. So let's just remove the container and then replace it with a drag target. So we can actually drop our draggable feedback into here. And we won't have anything for the builder, but let's just return nothing. So container. And what we again only care about is the on accept. And this will take in an inventory slot. Just as for the drag targets inside of our inventory slots. Okay, now let's go back into our inventory storage widget and then let's just print dropping. Okay, now we'll use we'll format this text by using the $sign and then curly braces and then typing what variable we want to print. So let's say inventory slot dot block, then a comma, and then again inventory slot dot block dot inventory slot dot count dot value. Right, let's restart our game. Let's go into the debug console and let's actually pick up a few things like this cactus over here, and again this one. Let's split this up actually. So let's try dropping it here. And yeah, so we get dropping blocks dot cactus count 2. So 2 is our count. Let's actually go into our inventory storage widget again. So yeah, we're printing dropping inventory slot dot block. In our case, it was a cactus, and then inventory slot dot count dot value was 2. So again, if we do it to the right side, we should also get that print statement. And yeah, we see 2 here. Right. Now let's figure out the direction of dropping a widget or, dropping a block. So if we put it to the left drag target, we want it to drop at the left side of the player. But if we drop it at the right drag target, we want it to drop at the right side of the player. So let's create a new parameter for get drag target, and it'll take in a direction enum that we created before. This will be inside of our game methods. So yeah, we've created a direction enum. We'll use this here. And let's call it direction. And so for the first one, this will be in the left, right? So we'll pass in direction dot left. And this is the right one. So direction dot right. Let's add one more comma here saying to the. Now we'll just print direction. And since direction is just a single text kinda, we don't really need the curly braces. Right. Let's restart our game. Go into the debug console. Let's break a few sand, I guess. Let's split this. Now if we drop it here, we should get dropping block.sand 1 to the direction dot left, correct, and now to the direction dot right. Okay, but now how do we actually create item components for the inventory slots that we just dragged into here? Okay, so let's first just write pseudocode for this. So we'll iterate through each count in our inventory slot, or we'll iterate that number of times. So we'll create a for loop. Let's say we had a blocks dot cactus of, let's say, 10 count, and then the direction was direction dot left. So we'll create a loop that will loop around 10 times, and then it will spawn a inventory component at the left side of the player. So let's just do that. So first we need to loop through count number of times. So for integer I equals 0, I smaller than inventory slot dot count dot value, and then I plus plus. So we're just looping through each count. And for now, let's just do global game reference dot instance dot game reference dot world data. Now to as we know, to add an item component to our game, we'll just add it to the items list. So we'll do item list dot add now an instance of item component, and for the block we'll pass an inventory slot dot block. So for count number of times, we're just adding that block as an item component to our game, and this is actually nullable. Okay, now the spawn block index. So the spawn block index defines where the item component will spawn. So if the direction is direction.left, meaning we have dropped the item to the left, not the item, okay, let's just call it an item for now. We drop the item to the left drag target, so that the direction will be direction.left. We want our spawn block index to spawn a little bit to the left of the player. And if it's the direction is direction.right, we want our item component to spawn a little bit to the right of the player. So here we'll just create a simple, we'll just create an if statement here. First, we initialize a vector to spawning position. Let's actually do that inside of here. And we'll just check if direction equals direction dot right. So if it is right, we're gonna do spawn position. So we want this relative to the player's position. So let's get the player's position. Give methods dot instance dot player x index position. So we have two positions here, the player x index position and the y index position. So let's do vector 2. So player x index position for the x value, and for the y, methods dot instance dot player y index position. Right. And we want this to be a little bit to the right. So currently this just points to the player's position. So let's actually comment out this if statement and then see what this does. For the spawn block index, let's just put spawning position. Right, let's sort of restart our game. Okay, I'm gonna like break something like a grass block. Cool, and then I'm gonna drop it here. Now, yeah, we see that an item component has spawned. So we were not exactly able to see it because it was, happening behind the inventory GUI. But if I throw this again, it should have spawned here, and it did. Right. So, it's actually spawning exactly at the player's position, like right here. We don't want that. Let's make it so that it spawns at a slightly higher position. So to do that, we just, in the vector2.y, which is here, we'll subtract it by, let's say, 3 blocks. So now we should get something a little bit better. Let's see. Let's break this leaf over here. Then throw it. And I just actually picked it up. Oops. Okay, it's happening too fast. Let's actually make it like maybe 10. So that it'll take a little time for it to fall so that we can actually see it in action. Okay, let's pick this flower up. Throw it. And yeah, as you just saw, it spawned up from the sky. So rather than having it as 10, let's just make it 2. And now we'll just mess up, actually not mess up. We'll mess with the player X index position so that it'll spawn either to the right or the left of the player. So let's have the statement again. So if we want it to spawn at the right, we're gonna add the X position to something. So let's say reach amount of time. So what is reach again? Inside a constants we defined a value, a max reach, right? So we'll put that as that. So plus max reach. I'm doing max reach because it's better than doing just putting some random value here, right? And for the else, we'll do let's copy all of this. paste it here, plus, okay, not this, minus max reach. So if it is right, we're adding the index position to max reach, and if it's to the left, we're subtracting the x index by the max reach. Right, let's hot restart our game. Okay, let's pick this dead bush up and let's throw it here. And yeah, as you can see, it spawns. Right, and now let's try for the left, and it does for the left too. Right, now let's make it so that once you actually throw the items in the inventory slot, it actually disappears. So currently we're able to infinitely do this. We don't want that to be a thing. So oops, it's a bit laggy because of all the entities that have spawned. All right, so let's do that. So after we've created all of the entities, we're going to do inventory slot dot empty slot, and that's it. Let's hot restart our game. Let's pick up a few things, like, okay, 2 dirt blocks, okay, I mean grass blocks. Okay, so before everything, let's just fix that real quick. We, like, long ago we changed the mining speed of stone. So inside block component, let's go down to, not block component, I mean the resources of blocks. Let's go down to the stone. So blocks.stone, and here let's go here, actually the block data of stone, and then we'll set this to something like 3.5. okay, so now the block breaking speed of stone should be fixed. I think we changed that for some debugging purposes. All right, so let's pick up a few blocks again. So right, 2 sand, a cactus. Let's actually pick up 2 cactus, some dead bush. Right, now let's throw this. So I'm gonna throw the sand to the left, and it appeared there. All right, and this cactus to the right, and it appeared there. So let's actually go back into a inventory source widget, and then change the y index position to like -4 or something. Again, let's do minus max reach, so it spawns like fairly high. Right, or restart, so it just doesn't get trapped there somewhere. Right, okay, cool. Let's pick up a few things. Now let's try throwing them. Dead bush to the left, and it spawned. Let's pick that up. So exactly 1. Now let's throw away 2 cactus, and if we pick that up, that should be 2 cactus. Right, so everything's working. Now let's work on crafting. But what exactly even is crafting? Crafting is a process of creation of a new item by placing in raw materials in a crafting grid in a particular order. In our game, we'll have 2 different types of crafting grids. A player inventory crafting grid, that will be inside the player's inventory, and a standard crafting grid, which we'll get from a crafting table. We'll store these grids as a list inside of a class called Crafting Manager, which we'll have an instance of inside World Data. But how do we actually detect the specific placement of raw materials for a recipe? Easy. We'll first turn the crafting grid into a string. For example, let's look at the recipe for making sticks. We let the empty slots be E and the wooden planks be W. So the recipe for this would be WEE, WEE, EEE. But we cannot always assume that the wooden planks will be placed in this exact position. It can be placed in different positions like these, for example, which would create different recipe strings. Rather than hard coding all of these occurrences for all of our recipes, we'll have another way around this. There's something in common between all of these recipe strings, the occurrence of WEEW. So we can just check for the occurrence of WEEW in a crafting grid to see if it's a valid recipe for sticks. We also need to make sure that all of the other slots are empty. So we need some sort of effective string searching algorithm. This is where regex comes in. Regex is a tool for finding patterns within a string. They are usually used for input validation or for searching through strings. In Dart, we can define a regex like this. And we can use the hash match method that will either return true or false based on if the string provided matches with the defined regex. For example, this will return true and this will return false. So to detect a valid recipe for a stick, we'll define a regex with the pattern as WEEW and use the hash match method on the crafting grid string. But we also want to make sure that all other slots are empty. And given that an empty slot relates to the character E, we can put E along with an asterisk before and after WEEW. The asterisk is the repeating symbol. It means that the preceding character may be repeated 0 or more times. For example, the regex LO asterisk L will match with LOL, LL, LOOOOL, and so on. We'll pair the first E asterisk with the circumflex symbol, which will make it look for repeated E's from the first character, and the last E asterisk with a dollar sign, which makes it look for repeated E's till the last character. Now let's create the player inventory crafting grid, which is a row of a 2x2 crafting grid, an arrow, and an output inventory slot. The 2x2 crafting grid is simply but a column of rows with 2 inventory slots. Okay, so now let's create our crafting manager class. Inside it, we'll have the lists of inventory slots like for our player inventory crafting grid or our standard crafting grid, etc. Just as we have a list of inventory slots for the actual inventory, right? So, and we'll be having an instance of that inside of our world data. So it'll be something global to our game. So let's create it inside global. We'll call it crafting manager dot. Let's create the class crafting manager and the list of inventory slots. So for now, we'll just be creating the list of inventory slots for our player inventory grid, which will be a column of 2 rows of inventory slots, right? So we'll have 4 slots. Let's go into our inventory dot and copy this code actually, and let's paste it here. Before that, let's actually give our name for inventory slot. Let's call it player inventory crafting grid equals this. And we only have 4 slots, so let's change 36 to 4. Right. Now let's actually create the player inventory crafting grid widget, right? So it'll be on top of here. So let's go into our widgets, into the player inventory. So we'll just add it inside here, okay? So the dimensions of this would be half of the inventory's height. So like, it'll fit in here. And the width will be just the inventory width, right? So let's create a new folder inside widgets called crafting, where we'll have all of the widgets that's related to crafting, just as we did for inventory. Because, we have like these many widgets that's just for inventory, right? So to not clog up our widgets folder, we are creating a new folder called crafting, right? So here, let's create a file, player inventory crafting grid dot. It's a rather long name. You guys could name it something that's more reasonable, right? And this will be a stateless widget. Let's call it player inventory crafting grid widget. Cool. And let's first return a sized box with the height and width as what we just talked about now. Height as half of the inventory's height and width as the inventory's width. So let's do sized box and height as, let's go into our inventory storage widget. And here we have given the, here we've given the inventory slot size as slot size multiplied by 9.5. So 9 slots with some extra padding, right? So let's do So half of that would be something around like 4.75, but let's not do 4.75, let's just give it as 4. So height will be kmethods dot instance dot slot size multiplied by 4. So half of the inventory height, and then the width will just be the inventory width or the inventory dimension. So let's just copy this whole thing and then paste it as the width. Let's format this, and temporarily let's change it to a container so we can actually see it. And for the color, let's pass in something distinguishable like colors.red. That's fine. And we'll add it to our player inventory. So player inventory crafting grid widget. Cool. Let's hot restart our game. And yeah, we can see it, but it's not exactly aligned to our inventory. First, let's actually go into our player inventory crafting grid and then wrap this container around positioned dot fill and our container around an align with the alignment as alignment dot top center. Come on. So this should have helped it a little bit into aligning it to the top. Yeah, it did. Okay, so now to finally fix this, let's go inside of our inventory storage widget into the get drag target, and we'll wrap the drag target with a sized box with the height as the inventory storage size. So let's paste that in here, and that'll be the height. And let's replace the semicolon with just a comma. Let's hot restart our game now. And yeah, so it's actually aligned to the top of our inventory. Cool. So now let's go back to our player inventory crafting grid, and we'll replace this with a sized box again. Sized box, and we'll remove the color property. Right. And so basically our player inventory crafting grid will be made up of 3 widgets. It'll be a row of 3 widgets. One, the actual grid, then an arrow pointing to another inventory slot, which will be the output. Like let's say you wanted to craft a stick, you place 2 planks here, and then you'd get the stick inside the output slot, and there will be an arrow between it. Right. So let's create the row. And for the children, let's first create our crafting grid. Right. So our crafting grid will be a column of 2 rows. So just imagine that the crafting grid, one inventory slots accounts to S. So our crafting grid should look something like this, right? So a square of 4 inventory slots, right? So it'll be a row, actually a column of 2 rows. So a column, and we'll first set the main axis size to main axis size dot minimum, so it only occupies the space that it needs. And for the children, we'll have 2 rows, so row, and for this we'll also set the main axis size to main axis size dot minimum, and this row will have 2 inventory slots, so inventory slot widget. And for now, let's just give the slot type as inventory. We'll eventually change that to a different slot type that we'll create. And for the inventory slot, we'll pass in one of the inventory slots from the list that we created inside our crafting manager. So let's first go inside world data and add the instance of crafting manager here. Crafting manager equals crafting manager, right? Now let's go all the way back to here, and then we'll reference that crafting manager. So inside it's inside world data, so we can access world data by doing global game reference dot instance dot game reference dot world data dot crafting manager, then our player inventory crafting grid, and this will be the top leftmost inventory slot, so the first, so of 0, right? And let's format this up, and we want to repeat this again. So we'll select it and hold Shift Alt, then the down arrow key, and then we'll change this to 1. Let's now go inside of our play inventory and actually make this list a constant. Right, now let's restart our game and see what we have. So yeah, we have a row of 2 inventory slots, but our actual grid will be this row but duplicated down, right? So let's go inside our player inventory crafting grid again. This is the row and this is inside a column, right? So we'll just duplicate this row down once more. So let's hold Shift Alt, then the down arrow key, and we'll add a comma here. Right, so that should be it. Let's restart our game. And yeah, we have our grid. Cool. And it's just another inventory slot. We can drop items to it and stuff and everything. But we have an issue that is happening because we just duplicated this entire row down. So it's like, you know, the actual inventory data or the inventory slots of these chunks are actually not the chunks. These inventory slots are linked. So like, so, you know, we have the 0 and first inventory slots here. And then again, we have the 0 and first. So we'll change this to 2 and 3. So second and third. Right. So that should have fixed that issue. And now let's actually add the arrow. So the arrow will be an image that we have inside of the inventory. And that is the inventory arrow.png. This one. Let's actually copy its path by right clicking on it and clicking on copy relative path. Let's go inside player inventory crafting, and then just after our grid we'll have this. So it'll be an image, so image.assets, and then we'll just paste in this here. Let's fix up the slashes, and yeah, let's actually put a comma here, and let's see how this looks. Let's restart our game. Yep, so this arrow is actually quite big. We only want it to be small size, let's say 1/7 of the inventory height. So let's wrap it around a sized box. Oops, a sized box. And then we'll give the height as 1/7 of the inventory height. So the inventory height is, let's go inside of our inventory storage widget. And the inventory height is kmethods.instance.slot size multiplied by 9.5, right? So let's actually put that around brackets and paste it. And that divided by 7. So 1/7 of the inventory height. Let's see how that looks. Okay, so that's a smaller arrow, but let's make it 1/7.5. So it's a little bit smaller again. And yeah, I guess that'll do. Now, inside of our main row, this one, let's actually put some spaces and stuff here so we can actually see everything clearly. Yeah, inside of our main row, we'll set the main axis alignment property to main axis alignment dot space evenly. This will make it so that all of the children are like evenly spaced between each other. So let's restart our game. And yeah, so now these two are like, there's like equal amounts of space between all of it. Right. Now we'll add our singular inventory slot, which will... Now let's create the crafting inventory, which will open when a player clicks on a crafting table. And this is an entirely new inventory with a new crafting widget with a 3x3 grid. This will be the output slot. So again, this will be another child inside of our main row, right after this arrow image. And this will simply be an inventory slot widget. Slot type will be slot type.inventory. Now, what about the inventory slot? What slot do we assign to here? Inside of a crafting manager, we only have 4 slots for the player inventory crafting grid. So let's actually make it 5 slots. And inside here, we'll assign the 5th slot, or let's actually copy the reference to our inventory crafting grid list. So, and we'll assign the 5th slot to here. So 4. Right. Now let's restart our game. And yeah, we have it. Everything's looking good. Let's actually change the size of the arrow a little bit more. Let's say 8. So 1/8 of the screen height. That should be looking a little bit better. Yeah, and it is. But right now, if you look closely, it's not exactly vertically aligned as we want it to be. Like, it's kind of, the space on the top is greater than the space at the bottom. So let's actually give it some padding. Let's wrap the entire sized box around a padding, and we'll give it some top padding. So edge insets dot only, and let's remove the constant keyword, and then let's make it so that there is 1 slot size worth of padding. Or let's say the height of the actual crafting grid, or this crafting widget, divided by 3. So let's put some brackets and divide by 3. Let's also specify its top padding. Right. Now let's restart our game. So that should be a little bit padding at the top right now. And that is definitely not a little bit. So let's actually stick to our old idea of just having a slot size worth of padding for the top. And I feel like that would be a little bit excessive too. And it is. We'll divide this by 3. So we get a smaller padding. And yeah, that's looking perfect. Now let's create the crafting inventory, which will open when a player clicks on a crafting table. And this is an entirely new inventory with a new crafting widget with a 3x3 grid. Okay, so before creating our standard crafting grid, let's add the list of that inside of crafting manager. So let's duplicate all of this down. So Shift Alt and then down arrow key. And let's call this standard crafting grid. And our standard crafting grid will be a 3x3 crafting grid. And 3x3 plus 1 for the output slot. So 10. Right. So this is 2x2 plus 1. That is why we have 5. Cool. And now inside of the crafting folder, let's create the file standard crafting grid. Inside this, we'll have our stateless widget, standard crafting grid. And we'll actually copy paste everything inside player inventory crafting grid. So let's go to the top. Let's put a cursor on return. And then shift click where it shows position.fill. So everything. And let's click on Control C and then paste it here. Right. Now let's import everything. Like position from material, game methods from utils, and inventory slot widget, and then finally our global game reference. Right. So let's restart our game now. And then temporarily inside of our player inventory, let's comment out player inventory crafting grid and then add the standard crafting grid. We'll actually have a separate entire inventory for the standard crafting grid, like an entire new inventory that appears when the player clicks on a crafting table. But for now, for just debugging our standard crafting grid, we'll add this to our player inventory because we already have an easy way of opening it. Right. So it's the same thing, right? But we want this column to have one more row. So it'll be, it'll be like, an extra row of this thing repeated down here. And then we want one extra inventory slots in the row. Right. So let's go inside the standard crafting grid. And then this is our column. And it currently has 2 rows. This is the first row and the second row. Let's entirely delete the second row. Yep. And then add the third inventory slot widget. So let's actually copy this down, Shift Alt and then down arrow key, and 2. But right now, we're looking inside player inventory crafting grid, but we want it to link to the standard crafting grid. So again, inside crafting grid, let's actually select player inventory crafting grid. This will select all of the occurrences here. So it's all highlighted now. Now let's click on Control F and we'll type in what we want to actually replace it with, like standard crafting grid. I already have it typed in. I'm actually type it again. So standard crafting grid. So we selected it, clicked on Control F, and then on this little icon here, and then we typed in what we want to replace it with. And if we click on this icon here, it's gonna replace all occurrences with that. Cool. So it's changed into standard crafting grid. Right, now let's restart our game. And yeah, so now we have the row of 3 inventory slots. Now we just need to duplicate it down 2 more times with the, respectively linked inventory slots. So let's select this entire row and then hold Shift Alt. Then let's click on the down arrow key twice. And now if we hot restart our game, yeah, so we have our standard grid. So this is exactly what we want. But let's actually break this grass block. And let's put this inside here. It's linked. That is because we didn't actually change the grid indexes. So 0, 1, 2, now 3, 4, 5. So 3, 4, 5, and 6, 7, 8. Now finally for the our output slot. Our output slot is the last list inside of our list. So we have 10 slots here, and then the crafting slot will be the last grid. So, or the last inventory slot inside of our grid. So let's go inside standard crafting grid again, and then the last grid will, or the last object will have an index of 9. So that should be working. Let's break something like this dead bush right here. And yeah, so it's not linked. Everything's working fine. Now let's actually put this standard grid inside an entirely new inventory. So a new stack. So, an inventory storage widget with the new crafting grid that we just created. So let's go inside our play inventory and then uncomment this and comment this back. So now it should have reverted to the original player inventory crafting grid widget, and it did. And let's actually create a whole new inventory. So everything same here. So let's actually copy our entire return statement. And the only thing different here will be that we'll have the standard crafting table instead of the player inventory crafting table. And we'll have a different observable value for actually opening it. Like in this case, we are returning a container if the inventory is open, value is not true, right? So let's go inside crafting and then create a new file, which will be just like our play inventory. Let's call it crafting inventory. This will open when a player clicks on a crafting table again. And this will be a stateless widget. And let's name it crafting inventory. And let's paste everything here. Let's import OBX from get, global game reference from global game reference, position and align and everything else from material, and then inventory storage widget from our inventory storage widget. Let's remove this line, and finally our standard crafting grid. Right. And let's actually hot restart our game and go inside game layout, and then we will add this inside of our game layout. So constant standard inventory. So not standard inventory, crafting inventory. Right. We need a comma here. Okay, let's all restart our game again. Now, if we click on this, actually two things happen. First, it opens the player inventory widget. Then it also opens the crafting inventory because it opens to the same observable value, right? And since the inside game layout, since the crafting inventory is at a higher priority than our player inventory widget, it appears on top of that. That's why we are seeing our player inventory widget, or not the player inventory, the crafting inventory, rather than saying our player inventory, right? So let's make this crafting inventory open to a different value. So, inside our inventory dot, we have an observable called inventory is open, which is false by default. And if it turns to true, the actual inventory is opening, right? So just like this, we'll have, let's actually copy this. We'll have a value inside crafting manager. Let's call it first import rx from get, and we'll call it crafting inventory is open, right? And inside of crafting inventory, we'll change this value to world data dot crafting manager dot crafting inventory is open dot value, right? Now if we hot restart our game and then click on this icon, we see that the player inventory opens, right? Because right now our crafting inventory is linked to an entire other value. So we'll change the crafting inventory is open to true when the player clicks on a crafting table. But for now, for debugging purposes, just to see if this works, let's go inside of our inventory button. So yeah, here. And then let's actually comment all of this out. Before that, let's duplicate this down, Shift Alt and then down arrow key. And then comment all of this out by holding Shift Alt and then A. And we'll change this to inventory manager, actually crafting manager dot crafting inventory is open. And same here, crafting manager, dot crafting manager dot crafting inventory is open, right? Now let's hot restart our game. Now if we click on here, the crafting inventory should open. So this is an entirely new inventory and we are actually opening it via this button. And this actually, so that's working. So we can remove this right now and uncomment this by holding Shift Alt and then clicking on A again, right? So we'll eventually open this by when a player clicks on a crafting table. Cool. Now let's make it so that when a crafting table is clicked on with an inventory slot with a block or an item, it's going to break that crafting table. But if it's clicked on with an inventory slot with no block or item, it's going to open the crafting inventory. And if you click on either side of the inventory, you can close it. We will not be adding this logic in a block component level. Rather, we will be creating a new class called crafting table block, which will extend from block component. And then there we will override the on tap down and add this logic. And then wherever we need to render a crafting table, we will render this crafting table block component rather than a raw block component of it without this new functionality. So we'll put blocks such as this crafting table that have extra functionality inside of a new folder called blocks rather than inside of components. Because, eventually we'll have like, specific blocks such as this with different, specific features for all of the blocks. So our components folder will be super flooded. So let's, we'll add all of those inside the dedicated blocks folder. So let's create the file crafting table block dot. And this will just be another class called crafting table block. And to get all of the properties and functions and methods of a block, we'll have to extend it from block component. So here we'll just be adding all of the extra functionality, like maybe an on tap that's specific to a crafting table and stuff. So yeah, and we get an error here because we have to require or provide all of these parameters that block component require. So like one of the arguments that block component needs is the vector2 block index and integer chunk index. So rather than doing vector2 block index and then requiring this from crafting blocks, like required this dot block index and then passing it in a super, this is how you'd usually do it, but there's another better and easier way to do it. So we can just do let's remove all of this from here actually, and we can just do required super dot block or super dot chunk index. Oops. And let's remove this parameter from here, and required super dot block index. So what this does is, when we are creating an instance of crafting table blocks and we're going to pass a parameter that will go directly to our block component, so we won't have to like create a new field for it and then require it and then pass it to the constructor of the parent, right? And then inside super we'll provide the block as blocks dot crafting table, or let's do blocks dot crafting table, right? So that's it. So now this is just like any other crafting or any other block component. There is no difference whatsoever, but now we'll add this extra functionality for this. So what should actually happen when the player clicks on a crafting table? We want the crafting inventory to open, but if that's all we want to do, just click then open crafting inventory, that it would mean that that's no logic for us to break that block component or a crafting table. So we'll make it so that you can only open the crafting table if there is an item that you're actually holding in, like let's say right now you're not holding anything. So if you would, let's say the sand was the crafting table, if you were to click on it, we want to open the crafting table UI or the crafting inventory. But if you were all holding a block or an item and then you click on the crafting table, we want to break it. So yeah, so inside of a block component, we have down here, we have this on tap down function. So let's just override this from here. So override bool on tap down. Actually, let's just copy paste this whole thing here. It'll be easier for us. And let's remove all of this from here. And let's just return true, because it has a return type of bool. Okay, so super dot on tap down. So if we call super dot on tap down, it's going to break the block. So let's say if we, when the crafting table is clicked, it's gonna go into super dot on tap down, and the super dot on tap down is this, and this is just the logic for actually breaking the block, right? So we can add some logic here, like if statement, if player is holding nothing, then open inventory or open crafting table inventory, crafting inventory. But if the player is holding something, then break the block, right? And how do we actually know if the player is not holding anything? Easy. We can just check if the current held item, so inside our inventory, so we can just check if the current held item is null. And to get the current held item, we can use the current selected inventory slot. So if the current selected inventory slot is 0, we'll just check for inventory slots of 0. So now it would be sand, right? So inside here we'll do global game reference dot instance dot game reference dot world data. Now inventory manager. Now we can do inventory slots Now we need to get the current selected inventory slot. So let's actually copy all of this, paste it in here, and dot current selected inventory slot, which is an Rx. So to get the actual value, we need to do dot value, and we'll just check if the block of this is null. So if it is null, it means player is not holding anything. Right. And now we'll actually copy out of this again. Or let's create an instance of inventory manager. So let's do inventory manager. Oops. Inventory manager equals, let's copy everything till inventory manager and then paste it in here. Cool. And now we can just do inventory manager and replace till inventory manager with inventory manager. Right, so everything's a bit cleaner now. So again, to get the current held slot, we just, or the current held block of a slot, we just going to the inventory slots list of the current selected inventory slot. Right, and then we're basically checking if the block is null. If it is null, here we need to open the inventory slot or the crafting inventory. So to open the crafting inventory, just inventory manager dot inventory is open. Okay, not inventory manager. We need to do crafting manager. To get the crafting manager, let's actually copy till world data, paste it in here, and then do crafting manager dot crafting inventory is open equals true. And this is actually crafting inventory. Okay, so we actually get an error here because bool cannot be assigned to the variable type of Rx bool, because crafting inventory is open is an Rx bool. So to get the actual bool, you gotta do dot value again. So this is it. So again, we'll check if the player is holding anything. If the player is holding anything, then break the block. So super dot on tap down. But if the player is not holding anything, then open the crafting inventory. So this is the logic that is specific for our crafting table. That's why we cannot just add this inside block component. Like, we could have just gone here and inside on tap down, we could have just done if the block is crafting table, then do this, and if not, this. And but eventually maybe we have to do it for other blocks, maybe like 100 other blocks. So we'd have to like add all those if statements inside the block component. Rather than doing that, we're basically just creating a class extending from block component, and then we're overriding some of the functions and then adding something that's specific to that particular block. Right. And but while rendering, how do we actually render this instead of the just block component for it? So let's go inside main game actually, and here into the render chunks function. Okay, so here what are we doing? So if the list has a block component, or inside the chunk list, for each block, what we're doing is we're adding a block component, right? So this is not what we want. Let's say we actually placed a crafting table somehow. Okay, let's make it so that after we add a player component, or inside the onload of the main game, let's give our player a crafting table. So let's do world data dot crafting manager, or inventory manager actually, dot add block to inventory, and then we'll do blocks dot crafting table. Now if we hot restart a game, we have a problem. Okay, so set state call during build. Right, okay, so let's not actually add this inside main game. Let's go to our main game and then cut this from here. This is happening because when we're actually adding this, the inventory has not yet been built. So it's giving us weird errors. So let's actually go inside player component and then add this. So we're just assuming that the inventory will be built by the time the players added. So now we don't have access to world data. We have to do global game reference dot instance dot game reference dot world data. Right. So we just did this so that we could get a crafting table when the game starts. So okay, we get the error again. So I guess we can't do it here. Okay, we put this in a wait. So let's actually cut this and then go back to a main game. And then we'll actually just add it after a timer. Let's do future not delayed duration. For the duration, let's put duration seconds 1 dot then, and then just do this. So what does this do? It basically just waits for 1 second, and after the 1 second is over, it does whatever is inside the then. Okay, now let's not restart our game. So we're doing this because we're hoping that, okay, yeah, so I didn't think you exactly saw that. So when a game starts, we don't have the crafting table, but after an exact second, it appears. So that's what's happening. We're just delaying by a second and then adding the block to inventory, because the error was occurring because we were, when we add a block to inventory, we're changing the slot dot count and stuff. So changing the slot dot count causes the inventory slot to rebuild, but the inventory slot can't rebuild when it's not been built. So that was the error. So anyways, we have a crafting table. So if we place this, we're just placing a block component of it. When we click on it, nothing happens. It's just, this is just normal intended behavior, because inside of our main game, inside the place block logic, we're just adding a block component rather than adding the actual block that we just created with the specific functions of it. So we'll create some sort of if statement that will check if there already exists specific blocks that we created for it. If it does, then it'll add that instead of the block component. So inside of our blocks dot, let's create another factory function called get parent for block. So let's do that. Factory block data dot get parent for block, and then we'll take in a block's enum, so block, and then we'll have a switch statement. So not an if statement, a switch statement. And okay, so we'll first have a default. So a default happens if we haven't, okay, let's say we did case blocks dot sand, then do something, not sand, then do something. But if we haven't actually defined a case, it'll go to the default. So again, it's like the else for switch, right? So if it's in the default, we'll just return okay, it has occurred to me that it cannot be a factory function. Let's just call it block component get parent for block, and then we'll return a block component with the block and block index as we need. We'll take this from as a parameter, so vector2 block index, and then we'll take in the chunk index as a parameter too, so chunk index. Okay, but now here we'll do case blocks dot crafting table. If then we're going to return the crafting table block. So if you didn't understand what exactly is happening right now, I'll explain it just in a minute. But for now, okay, let's go inside of our main game, and where we are actually adding the block component. Let's do add block data dot. Now to let's actually go into our block data again, because we cannot actually access this unless we create an instance of block data. So let's make this a static, so you can access it without having an instance. Now we can, inside here, we can do block data dot and then access the get parent for block. And then for the block, we'll pass in whatever is in here. So the block parameter for this one and block index. Let's just copy all of this and paste it in the actual correct place. So this would be here. And yeah, now let's just remove this from here. Right. And same for the other add. Oops, that was a real bad voice break. Okay. And same here, we'll do add and then block data dot get parent for block, and then we'll pass in the same things here. So oops, not here inside of the render block or the render chunk function. Yeah, just under this add. And for the block, we'll just do block, and for the block index, we're passing in something here. Let's just paste that directly as this, and then chunk index. Yeah. Okay, so now what will happen is that if anywhere the block is blocks.crafting table, it's going to go to get parent for block, and then it's going to go into the switch statement. And then if it is crafting table, we're returning the crafting table blocks that we just created, or let's actually just call it crafting table block, because how plural? What is plural? Okay, right. So if it is a crafting table, if the enum is blocks.crafting table, we're returning the crafting table block with the extra functionality that we just created. But if it's not, so if we actually haven't created like a different class with extra functionality, it's just going to return a block component for it. So let's say we created like gravity blocks. So we created a new file here called sand block dot dot, and then inside there we added the functionality for sand to actually fall. So in that case, we do switch case blocks dot sand, then we'll return that actual class, right? So that's what we're doing. Okay, so now if we hot restart our game, nothing much should change, because yeah, these are all block components, but when we actually place it, it's gonna go. Okay, let's actually do a dry run first inside main game. If we are placing a block inside placing logic, it's gonna do get parent for block, and then when we're placing a crafting table inside the get parent for block, it's gonna go inside this case and then return the crafting table block. So this should technically not be a block component, but our crafting table block. So let's click on it, and yes, so our crafting table UI has popped up, our crafting inventory, right? So currently there is no way of actually closing this. So let's make it so that when you click on the right or left, it actually closes. So let's quickly go inside of inventory storage widget and into the drag targets, because the drag targets are here. Yeah, okay. So we'll wrap this drag target or this sized box with an inkwell. An inkwell is like a gesture detector. So we'll just do on tap. So if it is clicked, so either the left or right is clicked, we want to close the inventory. So we'll first check if global game reference dot instance dot game reference dot pool data dot crafting manager dot crafting inventory dot is open dot value. So if crafting inventory is open, so this will get called if the crafting inventory is open. If it is open and either the left or right is clicked, the drag targets here is clicked, then close it. So let's copy all of this, paste this in here, and then do equals false. Oops, false. How did I accidentally type in an entirely new word? Okay, anyway, now we have a crafting table. Let's place it. And if we click here, okay, you can see here that the cursor has changed, right? So this is because of the inkwell. And yeah, so if I click on either the left or right, the crafting table, the crafting inventory is closing. Okay, now let's try breaking this crafting table component. So now I have an item or a block inside, selected. Now if I click on it, yes, it is breaking. But if I click on it without anything, it's going to open the inventory. Cool. So that's exactly what we wanted. Right. So now let's go over everything that we just did. So we created a blocks folder for all of these blocks for which we need extra functionality. And we just extended from block component. We did required super.chunk index and required super.block index for the parameters for the parent. And then we overrided the on tap down and added the extra functionality. So we basically just checked if the player is not holding anything, then we're opening the inventory. But if the player is holding something and then the player is clicking, then break the block or break the crafting table. And finally, inside of a main game, rather than adding a draw block component for it, we are adding a block data.get parent for block, in which we are, we have a switch statement where we're checking if for specific blocks, we're checking if it's a specific block, and if it is, we're returning the new class component that we created with the extra functionality. And if it's not, just returning a normal block component. Right. Now let's create two different slot types. Slot type.crafting, which is no different than slot type.inventory, except for the fact that it's going to check for a valid recipe each time something gets added into any slot of type crafting. And slot type.crafting output, where we cannot drag anything into here or drag anything out. But if you click on one, it's going to add all of the contents of that into the player's inventory. So first things first, let's go inside game methods to our slot type enum and then define our two new slot types, crafting and crafting output. Okay, now let's first go inside items.background, and in this case, so let's actually add the cases for these. So slot type.crafting, we want these both to have the same background as the inventory background. Okay, so we'll just copy this path and then paste it in here. And same for slot type.crafting output. Return this. Okay, cool. Now let's go inside inventory slot. And let's actually copy the slot type.inventory. So just what we're returning here. Okay. Because our slot type.crafting will be super similar to that. So let's actually first add the case for that. Slot type.crafting. And just return this. And yeah, we won't be having any changes here. The only change will be that we'll add something inside of the drag target. Okay, so now let's add the slot type for crafting output. So slot type dot crafting output, and here the crafting output will be unlike all of our other slots, but fairly similar to the item bar. So we don't want to be able to drag anything out of our crafting output. So we just, if we click on it, we should get whatever's inside here into our inventory. This is to fix some updation issues that will occur if we actually, just worked on just dragging it. So we make it so that this will be just the get child. So the get child basically just returns the background and the number widget and the drag target. So we'll just return that. So get child. So there's no draggable functionality, but we'll have the gesture detector. So let's wrap it around a gesture detector. So when it's clicked, it's going to add whatever's inside here to the inventory. Okay. And we won't actually add the on tap right now. Now let's go to our crafting folder inside widgets and then into the standard crafting grid. And here, wherever we're doing slot type.inventory, we're going to change it to slot type.crafting. Right, so here, 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 and for the second row, here, yep, and finally for the third row, crafting, crafting, and crafting. But for the last one, which is the output slot, this one's a output slot, we don't want it to be a slot type of crafting. We want it to be a slot type of crafting output. Cool. And then same for the player inventory. So let's go down here. This will be crafting, 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 and finally crafting. Cool. Now let's hot restart our game. Now we shouldn't see anything much different, but let's actually break something and then put it inside of our output slot. Now we shouldn't be able to drag it out, but we are. Okay, so this is a problem. Let's see. Okay, yeah. So inside of our player inventory crafting, we forgot to change it to crafting. Oops, crafting output. Right, now let's restart our game again. Let's actually just try putting a crafting table inside here. And yeah, so we're not able to drag it out. Now let's make it so that when crafting output slot is clicked, we want whatever's inside there to come to inventory. So let's do that. Let's go into the inventory slot and then here inside this gesture detector. So we'll have an on tap and then we'll do now first we want to know what crafting table this is in or what crafting grid it is in. Like it could either be the player inventory crafting grid with the 2x2 crafting grid or the standard crafting grid, the 9x9 or the 3x3 crafting grid actually. So like if we had an output here and we clicked here, we'd want to actually decrement the slot and then add it inside the player inventory, but it would actually break if we were to decrement the slot inside the 3x3 crafting grid, because that can very much happen because there's no way of actually differentiating between the row here, right? So let's figure out some kind of way to know if what crafting grid that the player is actually using. So inside crafting manager, let's go here and then let's create a function that'll return bool, and then this will be called is in player inventory. So right, so we have a okay, wait, inventory, sorry, I spelled that wrong. So we'll know if it if we are actually doing the crafting inside the player inventory, if the player inventory is open. So we can just do if inventory dot inventory is open, then we'll return true. So if it is in player, so if it is in player inventory, but if it's not, we'll return false. So we'll do if game methods, or not game methods, global game reference dot instance dot game reference dot world data dot inventory manager dot inventory is open dot value. So if this inventory is open, then we have a way of knowing that we're actually crafting inside the player inventory. So return true. And if not, just return false. Okay, so now let's go back into our inventory slot. Then here we'll have an if statement. If global game reference dot instance, actually let's go inside of our crafting manager again and then make this a static function. Okay, now we can do crafting manager dot is in player's inventory. So if it is, just do add. Okay, we need to add it to the inventory. So global game reference dot instance dot game reference dot world data dot inventory manager dot add block to inventory, and the block will be, we know that it's in the player's inventory. So let's do global game reference dot instance dot game reference dot inventory dot world data dot inventory manager, actually crafting manager dot player inventory crafting grid, because we're inside the player inventory. And then we want to target the output slot, so dot last, then dot block, right? Cool. And then it's nullable, right? And if it gets successfully added, so let's actually put this inside an if statement. So if it gets successfully added, decrement the crafting grid. So to access the output crafting grid, we'll just paste this in and then do decrement slot, right? So that's it. Now let's hot restart our game. Let's try dying this here, and if we click once, yeah, it's getting added to inventory. Cool. But let's actually do something else. Let's break 2 grass and then put it inside here. Now if we click, we'll have to like individually get all the blocks to our inventory. This is super inconvenient. Let's say we crafted something that gave us a stack of 64, then we'll have to like individually click through all of the 64 blocks, right? So rather than doing that, let's put this around a loop. So this entire thing let's just cut this, and then for integer I equals 0, I smaller than we'll get back to that later, and then I plus plus, right? And what should I be smaller than? Till what count should we increment? So we'll increment till the count. So global game reference dot instance dot let's actually just copy this till player inventory crafting grid, paste that, player inventory crafting grid dot last dot count dot value, right? So if we had let's say 10 items, it's going to loop 10 times and then add it to inventory, right? So now let's see if this works. Let's break a few sand and let's put it inside here. Now if we technically click, what should happen? It'll go inside this if statement because it is inside the play inventory, and then to this for loop, and then it's going to iterate 2 times because the count is 2. So yeah, count dot value, and then it'll add it to the inventory, and if it gets successfully added, it's going to decrement the slot, right? So if we click now, and that didn't exactly work. We still only got 1 block in inventory. Let's see. Let's actually hot restart our game. I think that was the issue. Let's see. Okay, I have 2 cactus, and if I put this inside here, yeah, that is not working. Let's see. Okay, this might be because we're decrementing the slot, and we're decrementing a value that we're using inside a condition. So let's do integer, let's say iterate till equals, let's copy and paste this and replace this with iterate, what did I call it again, smaller than iterate till. Okay, cool. Now let's try if this works again. Okay, let's break 2 leaves right now. And yeah, so now everything's working. Cool. Now let's do the same thing for crafting a standard crafting grid, because right now we've just implemented this for is in play inventory. Now if it's not, basically do the same thing. So let's copy all of this, paste it in here, but for the standard crafting grid. The standard crafting grid, everywhere we're doing player inventory crafting grid, we'll change it to standard crafting grid, and that would mean this should change to 10 for the output, because 10 is our output. Like if we go inside standard crafting grid, oh, actually it's 9. Oops, good thing I checked. Right, now let's go into our inventory slot again, right? 9, and then finally here, standard crafting grid, or we could just do dot last, same thing. Okay, now let's restart our game. Let's place this crafting table down. Let's pick up 2 sand, go inside here, oops, with a free slot, and yep, same thing works, right? Now actually we don't really want this feature of being able to drag something to the output slot, because we want it to be immutable by the player. We'll just add something here if our recipe satisfies or something. So we can change the get drag target here. So we'll just like put an if statement or like a ternary operator. We'll check if the slot type, oops, not whatever that is, if the slot type equals slot type dot crafting output. If it's not it, so we'll put a not operator actually. If it's not crafting output, then you can show the drag target. If not, don't. So show nothing. So a container. Right, let's all restart our game and see if this made some kind of difference. So see, we didn't need to. So we shouldn't be able to drag anything here. And we're not. But it seems that something has gone wrong with our inventory slot. This is because of the container here. Let's make it so that we don't like do this here. Okay, get drag target, right? And then inside our get drag target, and in the on accept, we'll only do all of this. So let's select everything inside here, and if slot type not equals slot type dot crafting output. So yeah, that's it. So we're not going to be doing all of dragging functions and stuff if the slot type is not of crafting output. And yeah, and yes, we're not able to drag anything to here, right? That works. Now finally we need to do, we need to figure out some kind of way to actually detect a recipe each time something is added into a crafting slot type. So every time a new item is put in here, so every time, so let's actually place down this crafting table. Let's say we were crafting a stick, and just imagine that these are birch planks or something. So inside here we want to check. So if I put this once here, we want to check if this is a valid recipe for something. If it is, we need to add something to the output slot. And if it's not, then do nothing. So if we put it again, we need to check if it's a valid recipe again. So yeah, so inside of on accept, so this will happen inside of on accept, of course. In the end, we'll add an if statement. If slot type is slot type dot crafting, then for now we just print checking for recipe. Right, let's all restart our game. Let's go inside the debug console, and each time we put something here, we should get checking for recipe again, and again. And this will also work for a crafting table. So oops, kind of got stuck in there. Let's pick up something like this cactus, and We place something here. Yeah, we get checking for recipe. So we'll use this to actually run our algorithm each time something goes inside our slot type of crafting. And yeah. So currently in our game, our inventory slots can only accommodate blocks. But, that's only half of all the items that we're going to have in our game. We're going to be having a whole list of other items like weapons, tools, and ores, etc. The official name of this is going to be just items. And, why is it that we have it, have this as separate two blocks here? Now we'll make it so that the items cannot be placed. The exact definition of a block is anything that can be placed in our, perspective, but an item cannot be placed. So that's where the difference of block and items comes in. Right. So first things first, let's go inside inventory and then change this from blocks to dynamic. Oops. Blocks to dynamic. Now a dynamic means that it could be of any type, right? Now just like our blocks, we'll create a new file called items dot dot. Here we'll have the enum of all the items in order just as we did for the blocks. So you guys can copy this enum from my GitHub. So I'm gonna just select all of this and paste it inside here in items. Right. Now one more thing. Inside of our inventory item and number widget, we're using the sprite widgets to actually turn the sprite, get sprite from block, which returns a sprite, to actually display a block in our inventory, right? Like this. Let's actually make some changes to this. Let's go up here and just like our get block sprite sheet, we'll create another function that will return get item sprite sheet. We'll call it this. And this will return the item sprite sheet. So return, and let's just copy paste this. And for the path, let's pass in the relative path of this sprite sheet. So here, let's just cut all of this out. Yep, and let's fix up the slashes. And from cache looks inside of the asset/image directory, so we can remove that from here. Okay, and for us to use from cache, we have to load it at some point in time. So let's go to our main dot, where we are loading a bunch of images. So here we'll also load our item sprite sheet. So flame.images.load. And let's pass in the path for this one. Cool. Let's fix up the slashes again. And then remove assets/images. Right. Now let's go back to our inventory item and number widget. So here we could either check if the inventory.block is an item. If it's an item, we could use gamemethods.instance.get_sprite from block. And if it's a block, we'll do if it's a block, we'll do gamemethods.instance.get_sprite from block. If it's an item, we do gamemethods.instance.get_item_sprite sheet. But we actually need to create one more function that will return the get sprite from item, that will return the sprite of the item. So let's do items. So it'll be of type items enum that we just created, and item and sprite sheet. Sprite sheet equals get item sprite sheet, and then return sprite sheet dot get sprite 0, and just as we did here, item dot index. Cool. Yeah. And now, so getting back to our logic here, we could either check if it's a block and then return get sprite from block, and check if it's an item and then we'll return get item from block. So okay, let's actually just do that for simplicity. We'll check if the inventory slot dot block equals block. Okay, so here we have another problem. We cannot exactly use the equals operator. To check if it is of type block, we'll use the is operator. So is blocks would return true if the inventory slot dot block is an enum inside of blocks. Right, so if it is, then do this. If it's not, game methods dot instance dot get item sprite sheet, and we'll pass in inventory slot dot block. Okay, and we seem to have a problem. The argument type, oops, not item sprite sheet, get item or get sprite from item. Right, yeah, that's it. Now we technically should be able to accommodate items in our inventory slots. So let's actually go inside of our main game, and inside the onload, after this delayed, we can add something else to inventory. Let's try items dot, oops, we need to import items first, dot apple. So okay, so we have a problem here. The item, okay, so let's go into add blocks to inventory, and then we'll change the parameter to dynamic. Right, so it'll accept any type. Now let's restart our game, and let's see if everything works. Yep, everything does work. We do get an item, and we are able to actually have it inside of our inventory without getting any errors. Now let's actually try something. With this slot selected, if we click somewhere, we get an error. The items is not a subtype of blocks. So this is an error occurring inside of our place block logic. So our place block logic, every time we click, it'll get the index placing position, and then, just do all of this logic and then add that inside here. So replace block at wall chunks. And then, this logic is, has to make sure that what we are placing is a block, or what is inside the player's inventory, or what is selected in the player's inventory is of type block. So let's add so let's add one more statement here with the AND operator. And to get the current selected block or the current selected item, so currently inside of our inventory slot, we are actually just calling it block. A block would just mean anything that can be placed down and not all of our items. But if we were to change this now, we'd have to change the occurrences in like tons of different places. So let's just imagine that we're referring to both items and blocks when we say inventory slot dot block. Okay, anyways, we'll check if the current selected inventory slot is of type blocks. Then only we'll proceed with the placing block logic. So let's actually copy this inventory manager inventory slots. So this will give us the current selected block. Let's paste this, and we'll use the is operator again to check if it is a block. Right, so this should be it. Let's restart our game. Right, now let's try placing our apple, and we cannot. Right, that works. Now let's actually try throwing our apple away here. Yep, as expected, we do get an error. So type items is not a subtype of type blocks. So this is a problem inside our on component, or not non-component, our item component. So here for the parameter, we're just taking in a block, right? So we'll change that to items, or not items. We also want it to be items and block. So we'll make it a dynamic, so it can be anything. Now let's actually go down here into the onload. And yeah, so we can remove this await. Right, so this is where we are actually getting the sprite. And we should only do this if the block, okay, here we can change this to item because, you know, there's only some occurrences. We can deal with this. And let's just change item everywhere. Item and item. Yeah, so we should only do get sprite from block if the item is of type blocks. So let's add the logic for that. So if item is of type blocks, then do this. If not, do game methods dot instance dot get sprite from item, and then we'll place in the item. Cool. Now here, let's go down here, and then we'll change block to item, right? And then finally, inside of the inventory storage widget, the block to item. Right, now everything should be fixed. Let's all restart our game. We've got an apple. Now if we throw it out, we should get the item component for it. And yes, we do. Let's see if we can pick it up. And yeah. So first things first, let's create our check for recipe function inside of crafting manager. So this will be a return type of void because we will not be returning anything, and then check for recipe. Right. And our logic will be slightly different for the player inventory and standard inventory grid. For example, if we detect a valid recipe inside the player inventory, we want to set the count and product of that recipe to the output slot of the player inventory, right? So the last slot of the player inventory crafting grid. And if the recipe was valid inside the standard crafting grid, we want to set the count and product of that recipe to the last inventory slot of the standard crafting grid or the output slot. So that is what will be different. So let's part this with an if statement. So we'll check if is in player inventory, then player inventory logic, and if it's not, standard grid logic, right? So first things first, for us to do any of our functions, we need to turn our crafting grid into a string. For that, we need the key of each recipe. In the key, it will be defined what block relates to what string. For example, as we have mentioned, in the standard crafting grid, the recipe for a stick would be WEEW. Or as a grid, it'll be WEE, WEE, and WEE. So basically just two birch planks. Okay, not W, yeah. So basically just two birch planks, just put one on top of each other. So just like this. And it can also be W like this. So yeah, we're checking for the occurrence of WEEW. And if we wanted to actually convert the crafting grid into a string, for this, we'd say blocks.birch equals W. So after we provide in the regex as WEEW, we'll set the blocks.birch as W. Or if we did, let's say blocks.diamond instead of blocks.birch, it'll look for a diamond in this formation of W, and then check for the recipe and add a stick there. So yeah, that is why we're actually defining the keys. So before that, let's actually create a recipe class. So recipe class recipe, and let's make all of the properties final. And first of all, we need the regex recipe, of course. Then the product. The product can either be a block or an item. So dynamic product. And then the number of product. So integer product count. And finally the key, which will be a map key. So for our stick analogy again, we do blocks dot birch planks relates to the W. So our recipe would be WEEW or something, right? And we need to actually take this in from a constructor. So let's do recipe and require all of this. Required this dot recipe, required this dot product, required this dot product count, and finally required this dot key. And for now, for debugging purposes, let's not have a list of recipes, like a list of all of the recipes in our game. We'll just have a singular recipe that we'll check for. So let's do recipe stick recipe equals now recipe, right? So let's define this for a 2x2 a player inventory grid. So regex, actually let's do this for a standard recipe grid. So stick recipe for standard grid, and we it's a string, so we'll put the quotation marks and WEEW. This is the pattern of occurrence for each recipe of a string that we want, right? And we also want to make sure that all other slots are empty. So first we'll do E asterisk in the front and then E asterisk after this. So this will check for E one or not one, 0 or more number of times. But this also could not work actually. We want, our logic will only work to check if every other slot is empty if it's checking from E 0 or more number of times from the first character, and E0 one or more times, not one or more times, 0 or more times to the last character. So we'll put a circumflex symbol here and then a dollar sign. So this basically tells check from the first character, and then the dollar sign check from the last character. But we cannot exactly use a dollar sign because we use it for formatting strings and such, right? So we'll have to put a slash on the back of it for it to actually work, right? And the product of this recipe is going to be a stick. So items dot stick, and product count, let's say 4, and key. We don't have to define what E means, but we'll define what W means. We'll in our logic, we'll make sure that if it's an empty slot, it'll automatically check, turn that into an E string. But yeah, so we'll only have to define this key for all of the new things that we define that's not E. So blocks dot birch planks will relate to W. Okay, cool. Now let's create a function that will turn our inventory crafting grid into, or not our crafting grid in general, into the string. So yeah, this will return a string, and let's call it turn crafting grid into a string. So we'll actually take in a list of inventory slots as a parameter, inventory slot crafting grid, and let's just return this for now. And what is exactly this? What crafting grid are we putting in as a parameter? For example, if we wanted to turn the player inventory grid into a string, we do turn crafting grid into string, and then we'll pass in the player inventory crafting grid. But if we wanted to turn the standard crafting grid, our 9 into 3 into 3 crafting grid into a string, we do standard crafting grid, turn crafting grid into string with our standard crafting grid, right? So we're just passing in the list because if we wanted the naming to be specific to each crafting grid, we'll have to create two functions, like turn player inventory crafting grid into string and then turn standard crafting grid in a string. So to avoid that, we're actually taking in the grid as a list. Cool. We'll actually have a list of, let's say, a string or grid string equals nothing for now, and we'll return grid string. Right, so let's say in grid string we had three different strings. Hello, I am Adi. So you could turn this to a combined list, like hello, I am Adi. We could combine all of this by doing dot join, and then yeah, that's it actually. So if you do dot join, it's just going to combine all of the strings inside the list, right? And we'll iterate through each in crafting grid and then see if it matches with a key. If it matches with the key, let's say a birch plank was there in one of the blocks of the crafting grid, we'll set that as W and then add it to the grid string. That's it. But we also need the key, right? So let's take in that too. Map key, right? So let's iterate through our crafting grid. So crafting grid dot asmap dot for each integer index and inventory slot. Right, so we have our individual inventory slot. Now we'll first check if it is empty. If it's empty, the inventory slot dot block or something will be null, right? If it's null, we want it to be E. So our whole logic is based on that. So we'll do if inventory slot dot block equals null. If then we're gonna add or do grid string dot add E. So let's say everything was null inside our inventory, so it'll just be E till crafting grid's length by the end, when we're returning. And if it had a stick or something, with the key providing it to the letter W, we'd have W here somewhere or something like that, and then we're finally just joining it together. Oops, Control Z. Right. Right. Now we'll have the else if, and we'll first check. Let's say we had another item in here. Let's say, okay, a birch plank. So this will relate to our stick. So we'll check if a key for birch planks is inside our key. Like if the key was for the stick, it would be inside the key, right? So to actually check that, we'll do key dot contains key, and then we'll pass in inventory slot dot block, right? If it does, then grid string dot add key of inventory slot dot block. Let's say the key was blocks dot stone equals to S, and we had a stone come up inside here. So if we do key dot contains key inventory slot dot block, and if the inventory slot dot block was an actual stone, it'll check if it had a key, and this is the key, by the way. So yes, it does contain a key. So it'll go inside this if statement and it's gonna add grid string dot add key of inventory slot. So this is just like an array, but rather than passing integers, we're passing in inventory slot dot block, which is stone, so it's gonna return S, right? So that's it for turning our crafting grid into a string. Now let's go back into our check recipe and then cut both of these out, and we'll just print checking okay, or crafting grid string, and we're gonna print turn crafting grid into a string. And then for the crafting grid, we'll pass in our standard crafting grid. And key, we'll just check for the sticks. So stick recipe for standard grid dot key. Right. And inside of our inventory slot, here, when inside the on except, if the slot type is of crafting, we actually want to check if the recipe currently is valid. So we'll do global game reference dot instance dot game reference dot world data dot crafting manager dot check for recipe. Right. Now let's run our game. Okay, so let's place this crafting table down, and let's actually place in an apple. And yeah, so for our crafting key for the recipe, we have only defined a stick to be as W. Actually, let's go back into a crafting manager. Yeah, so we have only a birch plank to relate to W. So let's change it to apple. So not an item dot apple, actually items dot apple, because we have an access to that. And inside of our main game, where we are actually giving ourselves the apple, here let's just duplicate this down a few more times. Let's hold shift alt, then the down arrow key, so we'd have a good number of apples. Right, now inside of the debug console, yeah, let's place it down. And if I place it in here right now, it's going to think it's a stick, but that is totally fine. And yeah, we get WEE. So the first block or the first inventory slot has it as W. Now let's actually split this by holding it, and let's put it here. So now we should get WWE, and we do. Cool. Now let's put this here actually. WEEW, and let's put this the last slot. So WEE, EEW. Yep. Now let's go back here into our crafting manager, and let's remove this. So to actually detect for the recipe, we need to check if the regex for the recipe, the actual recipe. So we'll do stick recipe for standard grid dot recipe dot has match, then turn crafting grid into a string. So we're checking if the actual crafting grid matches with the regex. So inside this if statement here, we're gonna do if stick recipe for standard grid dot recipe, then we can use the has match method, and then pass in the actual string, which is turn crafting grid into a string. And then for the crafting grid, so crafting standard crafting grid, right? And for the key, we'll just pass in stick recipe for standard grid dot key. Okay, and if it matches, so this means that the actual, what's inside of the inventory matches with the actual recipe. In this case, this will be the actual match. If it does, we want to set the output slots block to a stick and the count too. So we'll do, to get the actual output slot, we'll do crafting or standard crafting grid, because we're inside of the else, which is for the standard crafting grid. And we do standard crafting grid dot last to get the last inventory slot. Our output slot is always the last one inside our list. And dot block equals recipe or stick recipe for standard grid dot product. And then we also want to set the count to that. Standard crafting grid dot last dot count equals stick recipe for standard grid dot product count. and this is dot value. Right. Now let's see how this looks. Let's hot restart our game. And let's place our crafting table down. Let's assume an apple relates to a stick. And if we place it correctly, yep, we do get the stick inside of our inventory slot. And if we place it here, we still get it. This is not ideal. So let's do something here. We'll have a return type of bool, and here we'll return it as false by default, and then if it is done, we'll return true. If the actual recipe is valid, we'll return true here. So here it means that none of the recipes actually accounted for, none of the placement inside of the grid accounted for a recipe. So we'll set the output slot. So standard crafting grid dot last dot block or last dot empty slot, and then same for the player inventory crafting grid dot last dot empty slot. Now let's see how it looks. Let's place our crafting table down and let's put it in our correct formation. And yep, so if the formation breaks, it just disappears, right? And as you can see, our stick formation works in different slots, because let's go into a debug console. Actually, we didn't print it, but anyway, it's accounting to WEEW. And then finally we can turn this into a stick, and it's actually put this inside of our inventory, and yeah, now we have an actual stick. But one thing, we can technically, if we do this again, we can get infinite amount of sticks. We want all of the blocks inside of our grid to actually disappear. Not all of the blocks. We have 3 and 2 now, but once we craft once, we want it to be 2 and 1 here, because one each apple was taken it from our grid for the crafting. So let's actually create a function for that. So we just iterate through each inventory slot, and then if the slot isn't empty, we're gonna decrement the count. So we'll have a return type of void, and let's just call it decrement 1 from each slot. And we also need the actual list of inventory slots or our grid. So inventory slot let's just call it grid, and let's iterate through the grid dot asmap dot for each integer index and inventory slot. And we only want to do this if the slot isn't empty. So inventory slot dot is empty. So if it's not, that's why we put the not operator. And then we're just going to decrement the count. So inventory slot dot decrement slot. Yeah, that's it. And after a recipe is valid, meaning the output has been selected, actually not here, inside of our inventory slot, inside of our case for crafting output, after all of this, if we actually click on it, we're going to do global game reference dot instance dot game reference dot world data dot crafting manager dot decrement 1 from each slot. And let's actually cut this, and we have if statements for these. For example, this if statement is if it were inside the player inventory. So after all of the items have been put into the inventory, we access the player inventory. Let's actually just copy this little player inventory crafting grid and then paste that in here, right? And then let's copy all of this, and then same inside the else. And this will be for the standard crafting grid. So let's hot restart our game. So after the output slot has been clicked and all of the items inside the output slot has been put into the inventory, we're going to decrement one from each of the slots. Cool. So let's see. Okay, let's place our crafting table down. Apple. And yep, now if we click, this should turn into 2 and this to 1. And it does. Cool. And after this has happens, we also want to check for the recipe again. So since we already have a, right now it only checks for a recipe when an item gets put inside the inventory. But when an item gets taken out of the crafting slot, we want to check for it again. We are not currently, that's why we don't get a stick here. So again, at the end of this on tap, just gonna do check for recipe, but we need the instance of crafting manager. So let's copy all of this, paste it in here, and then dot check for recipe. Let's all restart our game. Let's place our crafting table down, split it, and yep, so even though I just took one out, I still have this here. And yeah, so that is currently exactly working. And now finally, let's do the same thing for our player inventory crafting grid, because right now inside of the crafting manager, here we're just checking it, inside the else statement here for only the crafting grid. We're checking for the recipe only for the crafting grid. So let's copy paste all of this actually and paste this in here. And you'd think that we only have to change, not standard crafting grid here. We're gonna pass in the player inventory crafting grid, player inventory crafting grid, and player inventory crafting grid. And you would think this works, but let's actually test it out. I'm gonna open the inventory, paste this here and here, but it doesn't. But if I place it in here, it does. That is because our actual recipe is WEEW. So WEEW. And of course, it only works for WEEW inside of a standard crafting grid. So for the player crafting grid, the recipe would be slightly different. It would be WEW. So let's actually duplicate this down. Let's hold Shift Alt and then down arrow key. And we'll change standard to player. And then we'll take away one E from here. And then we'll do stick recipe for player grid. And stick recipe for player grid. Stick recipe for player grid. And finally stick recipe for player grid. Right, now let's all restart our game. And now it should be working, because so this is the entire reason why we are eventually going to be having two lists for the recipes of our player inventory crafting a grid and our standard crafting grid, because it's going to be slightly different. So now it should work. And yeah, it does. So now let's add all of the recipes for all of the items and blocks in our game. So in my GitHub, you will find two lists, one for the player inventory grid recipes, which have the recipes for a stick made from a dead bush, a normal stick from birch planks, crafting table, etc. And then in the standard grid recipes, you have all of that, but with slight changes. Like here, it's WEW, but here for the stick, it's WEEW. Right, and here we have wooden shovel, wooden pickaxe, etc. So let's copy this and we'll paste this inside our recipe class. And again, I have refactoring homework for you guys. So let's select this, press Ctrl F, and then change it to recipe. Right, and we'll replace all. Cool. And we'll make both of these lists static, so we can access it outside of an instance. Cool. So here we're currently just checking for a stick recipe, right? Both of inside of a play inventory and a standard inventory. But we don't want that. We want to iterate through each of our recipes and then check if it's valid for any. Let's actually cut this, and then we'll iterate through recipe dot player inventory grid recipe. So this is a new list of all of the recipes, right? So this is for a player inventory. So we'll iterate through this. So asmap dot for each integer index, and then finally recipe. So we have our individual recipes here, and we'll paste this inside here. And now we'll actually cut these out and change everything to our individual recipe that we're iterating through. Recipe, and finally recipe. But as you can see here, we cannot exactly return something because for each is actually a void, or it's not considered as an exact loop. So we're gonna have to make a few changes. So we'll cut this out and we'll make this a for loop. So integer index equals 0, and index will iterate through our player inventory crafting grid recipes. So recipe dot player inventory crafting grid recipe dot length, and then index plus plus. And for the individual recipe equals recipe dot player inventory crafting grid recipe. So we have actual list and an index. Now we just need to do that recipe of index. So in the first iteration, it would be the first recipe, then the second recipe, then the third, etc. So yeah, and let's put our curly braces here, and let's do for the same inside here. So we'll cut all of this out and then do recipe dot standard grid recipe. So now we're iterating through all of the recipes for our standard grid. And oops, where was that again? Here dot asmap. Oops, not like that again. And a for, so integer index equals 0 until index is smaller than recipe dot standard crafting recipe dot length and index plus plus. So we'll have an index going from 0 to length of standard grid recipes, and then we can get the individual recipe by doing recipe dot standard grid recipe of index, right? And then we'd set the recipe to this one, and let's paste this back in here, and then we'll change our stick recipe for standard grid with our recipe. Cool. So this is it. Let's not restart our game. So again, we're just iterating through each one of our recipes for our respective inventory, or not our inventory, our crafting grids, and then we're just checking if it matches. If it does, we're setting whatever the output to is to whatever the recipe's output should be. Right. So there's tons of stuff here. You guys can take a look around it, but we'll cover most of it. First, let's pick up this dead bush, and if we put this inside here, we get one stick. Cool. Now let's see. Okay, with the power of editing, I have found a birch tree. Now let's actually cut this down. Let's just punch this, and here inside of our player inventory grid recipes, there's a recipe for birch planks. There's just a W, with the W being birch logs, and then the product count is birch planks of 4. That means we can just place this inside somewhere here, and then we'd get 4 birch planks. And now let's actually break one more log, so we get a little bit more amount of birch planks. And when we start off, the player will not have an actual crafting table, and they'll craft one by putting 4 birch planks in this position. So yeah, so we have the recipe for that right here. So BB with the B as being birch plank. Right. Now, oops, let's not create a birch plank right now. Let's just create a few more sticks. And oops. Yeah, so we don't have the updation working exactly for this one. So let's see what the issue is. Let's go inside of a crafting manager. And in our check for recipe, we are going to remove the return true from here. So that is what's causing the issue. And yeah, that should be it. Right. Now the updation issues should have gone. Now I'm gonna get a birch plank again. Okay, so I've got some with the power of editing, and we can actually make sticks, but we cannot. Let's see. I'm just go inside of a player inventory grid recipes again, and let's see what the issue is. Yep, we changed this to apple instead of birch planks. So we need it to be blocks dot birch planks again, right? And it's actually to make our lives easier for us. Let's go inside main game, and then here let's just give the player a bunch of stuff, like maybe blocks dot birch log. Same here, birch log. Oops, blocks dot birch log, and we'll cut this out. The apples here, we don't really need apples anymore, and then we'll duplicate this down, and yeah, we're actually able to craft sticks, right? So what just happened now was also a mistake, since after we have a recipe and we take an item off, we are still getting the actual product. So to fix that, let's go inside of our inventory slot, and inside the draggable of our crafting slot. Yep. Here we'll add an on drag started, which will get called every time a drag starts. So if that happens, we want to check for the recipe. So go down here and let's copy till crafting manager and then paste it here. So crafting manager dot check for recipe. Right. Let's not restart our game. So now we won't have any exploitation issues or anything in our game. So let's try that out again. Let's place this in here and take that out. But we still get it. Let's see. Let's put an if statement here, just a print statement saying started drag. Let's all restart our game. And let's try putting in something. And if we start a drag here, we do get an if statement. So I guess we cannot exactly update it when an item is being dragged. So we'll change it to on drag complete. Let's see if this works. And we can place something here and take it off. And then so now no exploitation issues will occur. Right. So now let's actually just test out some of the recipes. So we have tons of recipes inside of a crafting manager, inside global, where again, yeah. So here we have a recipe for birch planks, crafting table 2, a wooden sword. So let's make these now. We need birch planks first. Okay, let's place down the crafting table and let's make some sticks. Okay, so again, never mind. The crafting table sticks recipe is still broken. So here, let's see, stick for actually standard grid. And yes, one E is actually missing from here. That is what caused the issue. Now it should be working. And yeah, now it's fixed. Now let's try crafting a sword. This is the actual recipe for a sword. And let's try putting this back again. This is happening because a stick occurs before a sword inside of our recipe. So let's temporarily just comment this out. So now let's try crafting a stick inside of our play inventory. We'll take it from here. And we'll make the sword inside of our crafting table. So let's click on it with an empty slot. And yeah, we do get a sword. And now let's try for a pickaxe. A pickaxe would be in this formation. And yep, so everything is working. You guys can check through the recipes if you want. So currently we won't exactly have the recipe for a stick here inside of the standard grid recipe, but it's totally there inside of a player inventory grid recipe, so it's fine. Right, so we have tons of stuff here. You guys can look around this. Now let's make it so that the tools in our game cannot stack. For example, if I add a shovel into my inventory and then add one more again, it wouldn't go into this slot, but would get added into another. A tool will be specific items in our game which will have specific functionality related to mining. We'll simply add a tools enum which would relate to different tool variations. Now let's go inside of our items file inside resources and let's create our tools enum. So in our items we have lots of different things like swords, shovels, pickaxes and axes. So a sword, shovel, pickaxe and an axe will be a tool, and for everything else that will not be a tool like coal, diamond, apple, which we want to stack up to 64, we'll have a tool type of none. So let's create our tools enum. And we first have none for everything that's not a tool, and then sword, shovel, pickaxe, and finally an axe. Now let's create the item data class just as we did for block data, which just returns some basic properties of an item. So here we have is collidable, base mining speed, breakable, etc. So in our items, let's first create the class item data. And the property here, for now, we'll just have property of tools. So final tools, let's just say tool type. And we'll take this in from a constructor, but we don't exactly want to require this because not all tools will be, or not all items will be a tool. But right now we have a majority of tools like axes, pickaxes, swords, shovel, but eventually when our game grows bigger, we'll have more items which will be at a higher number than of the tools. So we'll make it so that we'd get the tool type defaulted to tools dot none. So now inside of a factory function that we'll create to actually return the block data of a particular item, we just need to have the cases for the actual tools, and then we could have a default which would return tool types of null. So let's go inside items and let's create a factory class. So a factory function item data dot get item data for tool, and this will have an item as a parameter, and then this will be a simple switch statement for item, and for default we'll return an item, just a simple instance of item data. So an item data of none, right? So an instance of item data will have the tool type as none by default. So now we just need to create the cases for all of the tools that do not, need to have an tool type of null, like our items dot wooden sword, for which we return an item data of with the tool type as tool type dot sword. Oops, not a tool type, or tools dot sword. Right. And let's actually fix that. It's sword and not sword here too. And as always, you don't really need to type all of these cases in. You can go into my GitHub and then copy this exact factory function and paste it as this. Right, so this is the same thing. So we have a switch statement for item, and it's called get item data for, let's say, get item data for item. And by default, it returns a simple instance of item data with the tool types as tools.none. And here we have cases for all of the actual tools. So golden shovel, we'll have a tools of shovel, and iron pickaxe, tools.pickaxe, etc. So right now we won't, we don't really need to know what the specific kind of tool it is. We just need to know if it's not a tools.null. If it's a tools.null, it'll either be an apple, stick, gold ingot, coal, etc., which we want to stack up to 64. But if it's anything else than a tools.null, it'll be either a sword, shawl, pickaxe, etc., or an axe, etc., which we do not want to stack. So to do that, it's actually quite simple. Let's simply go inside of our inventory and into the add block to inventory. And this is the actual, logic for incrementing slots. So we can just add an if statement here saying if we first need to check if the block is an actual item, right? Because it could either be of an enum of type blocks or items. So we'll first check if block is of type items. And now we'll check if, now we know that block is an item after this condition. So here we can do item data dot get item data for item, and for the item we'll place in block, and dot tool type. Okay, so we'll check if this is not tools. Okay, equals tools dot none. Right. So and it's actually cut this and then undo everything that we did. This okay. Anyway, we'll add it here. Let's import items again, and so here we'll put this code in, and we can just put this in an else. We can remove this condition. Actually, let's not remove this condition. Let's cut this condition off, and let's add another if statement inside of this else, and have this here. So what's happening right now? So we are first checking if the item, so just ignore the keyword blocks here. We're not, block here because we don't really want to change this to items right now because we're too far in to do that. So we're checking if the actual item, and notice here we are referring to item as either a block or an item. So if the, whatever is in the slot is the same as what's being added into the inventory, we want to increment the slot. So first, if we're checking if it's an item and if the item's tool type is null, only then increment the slot. But if it's a block, then just increment the slot. We don't need to check for anything because we'll take it for granted that every everything of type blocks can be stacked up to 64. Right, now let's restart our game. Let's make a sword. Let's turn all of this to birch planks first. and we need some sticks. And okay, so for some bizarre reason, okay, yeah, never mind. I totally forgot. We actually changed the sticks recipe to only occur for our inventory slot here, our player inventory crafting grid. And yep, so we have some sticks. Cool. Now let's craft our sword. So this can be any tool you like, but I'll just craft a sword because it's the easiest. So right now I have a sword, and if I click on this again, it shouldn't stack into this sword, but should be added into another inventory slot. And that totally doesn't work. So let's see. And okay, so this else statement is kind of wrong, because here we're both checking if it's an item, and the get item data for item block dot tool type equals null. So even if this fails, it'll go into this else. So we want to specifically check if the block is of type blocks, only then do this. And now our else statement specifically only increments count if the actual what's being added into the inventory is a block, and not if this if statement generally fails. Right. So now let's craft our sword again. Okay, now I'm gonna add this to my inventory. Yep. And if I add it again, this time it should work, and it does. So it's not getting added to the existing slot, but to a new slot. Right, and this should also work for different tool types. So let's create a pickaxe. And yeah, it does. Now let's try for a shovel. Yep, so everything's working. But finally, we have a small problem. We are able to drag our tools into another slot with a tool, and then we're able to merge them together. We do not want this to be a feature. So let's go inside of our inventory slot, into the get drag target, and into the else if, where we are actually checking if both have the same block and if the total additive sum is less than or equal to a stack. So if it is a block, okay, so if it's anything, if the item that's getting dragged in is anything other than a tool, then we can do is smaller than or equal to 64 or a stack. But if it is a tool, we'll make sure the stack is just 1. So yeah, so let's do that. So let's add our logic before our stack. So we'll check if the item data, okay, we first need to check if, let's put brackets. We first need to check if the dragging inventory slot dot block is of type items, and if the item data dot get item data for dragging inventory slot, dragging inventory slot dot block dot tool type is not tool types dot null or tool types dot null, none, then have a stack of 1, if not have a stack of 2. Right, so we have some problem here. Okay, so I think we cannot exactly put this here. So let's actually cut this code and create a function for it, which will return bool, and we'll call it get stack. And yeah, this should be it. Let's return this, and this will take in our dynamic of block, which we can substitute for our dragging inventory slot block. Same for this one. And okay, let's see, and let's actually remove this from here. Right, and now back up in our logic here, we can do get stack, and here we'll pass in our dragging inventory slot dot block, and oops, let's actually revert back to the actual num returning. So if this is true, return 1, and if not, stack, right? And here, yeah, we'll just do get stack, right? Now that should work. Let's create some tools. So let's first turn all of our wood into planks, and then these into sticks. Now let's place down our crafting table, and let's create some tools. Okay. Now, yeah, we're not able to drag them into each other. Cool. Now let's make it so that the block mining speed changes when mined with specific tools. For example, if you mine a soil with an axe, nothing will change. But if you mine it with a shovel of a wooden tier, the mining speed will slightly change. But if you mine it with a shovel of stone, it'll be of a higher speed. And then if it's gold, even higher than that, and so on. So each type of block will have a suitable tool. For example, a wood would only be able to be efficiently mined with an axe, stone with a pickaxe, and soil types with a shovel. And so we'll make some sort of function that will check if the player's mining a block with a suitable block or a suitable tool, and change the mining speed according to the tier of the tool. Like wood would be smaller than stone, stone smaller than iron, iron smaller than diamond, and diamond smaller than gold. Right. Now let's actually define the suitable tool for each type of block. Like we want a wood plank to be preferably mined with an axe, a stone with a pickaxe, a wood with another axe again, and soil with a shovel. So inside of our block data, let's create a new field called final tools. This will be of type tools, of course, and suitable tool. Let's require this. Required this dot suitable tool. Cool. Now let's go all the way down here. And for plant, it doesn't matter. Let's just give it a suitable tool as tools.none. For soil, let's accidentally messed up with the brackets there. For soil, we want it to be mined with preferably a tool of a shovel. Yep. And wood, axe, of course. Tools dot axe. Leaf, again, it doesn't really matter what we mine a leaf with, but we'll give it as an axe again. And for stone, we'll give pickaxe. And wood planks, that'll again be an axe. So tools dot axe. And unbreakable, let's just give this as none. Suitable tool, tools dot none. So let's now actually create a new file inside resources called tools.dot. And let's actually first define our logic here. So now let's actually first go inside of blocks.dot. Actually not here, inside of our block component actually. And into our block breaking component initialization. So this is a step time. Let's actually I'll put this in brackets. So this is our base mining speed. The base mining speed is, what will be the mining speed when the players are actually mining something with a fist or something. So we multiply this by values like maybe 0 0.3, 0 0.4, 0 0.5, 0 0.6, etc. Let's say if a player was mining with, okay, so let's imagine that our block component is a stone and that the player is mining with a pickaxe. So actually, let's specify it as a wooden pickaxe. So we'd want our, let's say, step time to be not the base mining speed, because we want our mining speed to actually increase when the players are actually mining it with a pickaxe, right? So we'll multiply this by like 0.6. So it'll be 60% of the original mining speed when mined with a suitable tool and a wooden pickaxe. If it were an iron pickaxe, we like change that to maybe 5. So 50% of the original step time. So half of the actual speed. So it's a bit faster. And maybe if it was diamond, we'd set it to like maybe 3, 5. And then finally, the gold will be our highest tier. So if it's gold, we'll maybe set it to like 25. So only 25% of the original mining speed. So we'll create some sort of function inside of tools here that'll return this double that will multiply with our base mining speed. Right, so now let's go inside here. So first things first, we want to make sure that the player is actually holding a suitable tool. So, if we were to mine, a sand with a pickaxe, we do not want the actual mining speed to change. We want it to be the base mining speed. So, let's say if you were mining a stone with a shovel, that wouldn't make too much sense. And, even if it's a gold shovel, we don't want the original mining speed of stone to change. So we'll first check if the player is currently holding a suitable tool for a block that they're going to be breaking. If yes, we'll do some logic. But if it's not a suitable tool or any tool of some kind, we'll just return 1. So if it is 1, let's go into our block component again. If it is 1, we'll be like, let's say get block breaking speed or something, or get block factor change or something. And if we return 1, nothing's gonna happen. It's just the step time is gonna be multiplied by 1. So it's just the base mining speed. And if you were to, let's go back into our tools. If we were to return like, if diamond or something, return 0.3. So if it is 0.3, if a get block factor change will be 0.3, it'll be 30% of the actual mining speed, right? So let's go inside here and then let's create a function. This will return a double, and let's actually call it get mining speed change, right? And first we want the actual tool that the player is holding, but we don't really need to take that in as a parameter. We can always use our global game reference. But one thing we definitely need is a block that the player is mining. For example, our logic is going to be based on what block the player is mining, of course. Like, we want to check if it's a suitable tool. To know if it's a suitable tool, we need to actually get the block. So we'll pass in the block that the player is mining into our get block factor change. Okay, let's go inside tools. Or get mining speed change, that's the name of our actual function. So block. And now let's have an if statement here. So we want to check if the player is holding a tool, because the player could be holding anything. Maybe a dirt block, maybe an apple, which is technically not a block. And so we only want our logic to happen if what the player holding is a tool and a suitable tool, to be exact. So a suitable tool will be defined on what the suitable tool for the block actually is. So first let's confirm that the player is actually holding a tool, and actually this won't be a block. Oops, dynamic, my bad. And let's call this held. Okay, never mind. This one is a block. Oops, block. And let's create a new variable, dynamic current held item, and we'll get what the player is currently holding. So we can actually get this by going into our main game, into the place block logic, And this one, world data dot inventory manager dot inventory slots of world data dot inventory manager dot current selected inventory slot dot value dot block. This is the item that the player is currently holding. I mean, I just did this because I didn't really want to type this all over again, but you guys sure can. And we don't really have access to world data. So let's do global game reference. And let's actually, rather than doing that, we'll do world data equals global game reference. Oops. Dot instance dot game reference dot world data. Right. So now we have the current held item. And let's just put this on top of our if statement just for better readability. Okay, so we first need to check if it's an item before it's a tool. So we'll do if current held item is of type items. Right, now only we can actually check if it's a tool, because we'll use the item data dot get item data for item factory function and then pass in the current held item. And then we can use the tool type. And then it will only be a tool if the tool type is not none, right? So we'll do equals tools dot none, actually not equals tools dot none. And one more thing, we discussed that we don't want to use other tools other than a suitable tool for mining a block. We don't want to use a pickaxe for mining a grass. So if we were mining a grass with a pickaxe, we don't really want the actual mining speed to change. We want it to remain as the base mining speed. So if it were 3 seconds and we put something here, we should get 3 seconds back. Whereas if the player was mining with a shovel, it'll be like 2 seconds or 1.5 seconds or so on. So we can just check here. We'll put another and we'll check if the current held item, we know it's a block right now. An item right now. So we can do this equals. Let's copy this again. Paste it in here. Dot, actually not this. This time we use the block data. The block data dot get block data for. And then now we are finally using the block that we are taking in as a parameter. And then we'll check if it's a dot suitable tool. Okay, so we're checking if the current held item is also a suitable tool. Right. So what are we doing exactly here? We're checking if the player is currently holding an item. And only then we can, if we were holding a block and then we executed this item data dot get item data for current held item, it'll obviously return us an error. That's why we're first checking if it's an item. And if it's an item, we're checking if it's an actual tool by checking if the tool type is not null, none. And we're finally checking if the current held item is actually a suitable tool for the block we are mining. Right. And now we'll have, bunch of if statements. If, let's say, wooden tool, then like return. Okay, we want the mining speed to change from, let's say the base mining speed of something was 10 seconds. So if we were mining it with a suitable tool, we wanted to change it to like 6 seconds. So suitable wooden tool. And maybe if it were an iron tool, we'd want it to be 5 seconds and so on. It'll decrease like that. So how do we actually know that the actual tool that the player's holding is of what type, right? Like we want to know if it's a wooden tool, an iron tool or something. So we need some sort of list to keep up with it. Like we could have a list here. List of items. You guys don't have to do this. I'm just doing it for explaining. List of items, let's say wooden tools. And we'd have a list of wooden tools like items dot wooden, axe, pickaxe, shovel, sword, etc. And I've actually made this list and you can get this from my GitHub. So I've made a list for stone tools, which is stone axe, pickaxe, shovel. And notice I've not really included the sword because we don't really need that here. So let's copy this and paste it inside here. And now we can know if it's let's go inside here again. If it's a wooden tool by doing if wooden, okay, what's it called again? Okay, yeah, wooden tools. If wooden tools dot contains current held item. Is that easy? So if it contains, if let's say this wooden tools list contains the item that the player is currently holding, let's say a shovel, it's going to return true, and then we'll just return whatever speed we want to change it by. So if it's a wooden tool, we only want to return maybe like 60% of the base mining speed. So let's actually make this an if statement, not an if statement, a switch statement. So it's a bit easier for us. Actually, let's not, cause that will actually we'd have to figure up with different logic to actually give us values based on it. So let's just make an if statement for now. And yeah, so this is wooden tier suitable tool. And if it's a wooden tier suitable tool, we'll return 0.6. So 60% of the actual mining speed. So it decreased by 40%. So if the base mining speed was 10, it's been decreased by 4 seconds and it's now 6 seconds. So slightly faster. Now we'll have an else if. We'll check if the stone tool contain the actual current held item. If it does, we'll make it 50% of the actual mining speed. So super fast here again. And another else if statement for iron tools this time. Iron tools dot contains current held item. And we're going to return 0.4 and so on. Else if iron tools, okay, this time diamond tools. So actually, we want a drastic jump between stone, wooden, and iron tools to maybe diamond or gold tools, because these are significantly rarer than all of these here combined. So rather than doing 0.3%, let's actually change it to maybe 2.5. So it's like super fast. So if the diamond tools dot contains current held item, then we'll return 0.2, okay, maybe like 0.29, right? Or 2.7, so that it's not super similar to 0.3. Okay, and then finally gold tool dot contains current held item, and we won't be making this something absurdly fast because our diamond and gold generation is, rarity is fairly similar. So you just make it so that it's like slightly faster than using a diamond tool, right? And finally, if none of these cases satisfy that, if it's not a suitable tool, then we'll just return null, meaning no change in speed, right? And let's see here, we're required to have an else statement here, and then we'll return 1 just because the function does not think that we're returning a null value, right? So that is it. Now let's go inside of our block components and multiply this by get mining speed change, and then we'll pass in block. Easy. And before everything, let's go inside of main game and into up here, right? Let's remove all of this for now, everything and except this. And here let's give blocks dot, okay, let's first test everything for a pickaxe. So items dot actually, so items dot pickaxe, okay, iron pickaxe. Let's duplicate this down, shift alt down, and pickaxe stone, shift alt down, pickaxe golden, shift alt down, wooden pickaxe, and then finally, not Dua, diamond pickaxe. Cool. So let's restart our game. Okay, so we've got all of our tools. Let's go mine down into a stone layer. And let's try mining something. Okay, so the mining speed seems to have not changed as much. So let's go back into our block component. And here, let's go inside get mining speed change. And put print here, print no speed change. Same here, print no speed change. Right, let's not restart our game. Since our mining speed didn't really change, there probably, something went wrong with our function. So let's try breaking. Okay, so we broke a sand with a pickaxe. So that was expected since that was not a suitable tool. But okay, again, so we get no speed change. Right, we need to differentiate this from this. So let's say no speed change 1, no speed change 2. Let's try that again. Let's go into the debug console. So right now we're going to try to debug what the actual problem is. So that should be no change 2. Yep. And right, super curious about this. And no speed change 2. Okay, so the actual problem is in here. So if the current held item is an item, okay, that is correct. Like, this is an actual item. And if item data dot get item for current held item dot tool type, so we were holding an iron pickaxe, so it's of type pickaxe, not equals tools dot none, and it is definitely not none because it's a pickaxe, and current held item equals. Okay, so we did an incredibly stupid mistake here, or at least I did. You guys probably saw this coming. So the current held item will never be our suitable tool because this is of type item, right? We actually want to check if the tool of the current, tool type of the current held item is equal to get block data for the actual suitable tool, right? So sorry, stupid mistake there. Let's see how this works now. So no speed change. Yep. Let's first try mining it with a fist. Right. And okay. Let's go into our debug console. Okay, we get no speed change again. I wonder why. So let's print some more stuff here. Let's print this, the current tool type, and also this, the actual suitable tool for the block that's being mined. So that should be the only hole in our system where, that something could go wrong. So yeah, let's actually just test it out. Why not? So no mining speed changes right now. Okay, so the tool is actually pickaxe and we were mining a soil. So of course the tool type is shell. Now, okay, let's see. Oh, we didn't get anything. Oh, right. So this means that our system is magically working. I think that's because we had an updation issue with not restarting our game. So yeah, apparently that works. Let's try mining it with a pickaxe. Okay, that is definitely faster than mining it with a fist. Stone. Yep. Now an iron pickaxe. Faster than stone. Diamond now. Totally faster. And gold. Right. Cool. Now this will also work the same for other blocks. Like if we try to mine a type of soil with a shovel. So let's actually do that. Let's go into our main game. And here let's do iron shovel. Oops, what was that? Stone shovel. So stone shovel, golden shovel, and wooden shovel, and finally diamond shovel. Let's not restart our game. Okay, now let's try mining some sand with a. Okay, so we got a problem. Let's see. Type null is not a subtype of items. Okay, that is not an actual issue. So let's remove this from here, because we had nothing in our slot. So the of course the item would be null. So now everything should be working. Let's try mining this. Right, normal speed. Now with the wooden shovel. Yep, faster. A stone shovel. Yep. Now an iron shovel. Okay, faster, definitely. Diamond, but that, okay, never mind, that was lag. Right. And golden shovel. Yep. So this will work the same for access too with trees. Right, so that's everything working. Now let's create the health and the hunger bar. This will be a row of a stack of 2 widgets. We link this to some sort of observable value. Okay, so let's add our health bar inside of the layout folder. Health bar dot. Let's specify that it's a player health bar, just in case. And actually, while we are in here, let's go inside widgets to inventory and to the item bar dot, and let's transfer it to the layout move. This is because it's more a part of layout than it's just another widget inside inventory. Right, and let's fix up the errors here. Let's import item bar widget again. Right, cool. Now let's go inside player health bar, and this, as always, will be a stateless widget. Let's call it player health bar widget, and let's return a row. Return row, and we gotta import it. And inside here we'll have all of the children. So like let's before that, let's create a function inside of this, and let's call it get heart widget or something, because we don't really want to create a new entire widget for this. And let's return a container for now. So inside of the children we'll simply have tons of get heart widget, and specifically 10. Right, so eventually we'll create the logic so that it would be an empty heart or a filled heart based on the actual health. So it would be super inconvenient if we were to actually programmatically define it like this. Like inside of the children, we'll add instances like here. But rather than doing that, we'll do it another way. We'll first create a list of widgets. Let's call it just children. And let's cut this from here. And we can add this here. And children is just a list of widget. So we can remove this and add children here. This is the same thing, but now we actually have the ability to programmatically add it inside of a loop. For example, let's create a simple loop that goes from 0 to 9. So integer I equals 0, I smaller than 10, and I plus plus. And here we can just do children dot add and get heart widget. So this is going to loop 10 times, and each time it iterates, it's going to add a heart widget inside children. And then after all of this, we are returning the row with the children property as this children list that we just created. You will eventually understand why we are doing it this way later in the future when we actually link it to an actual observable value. But for now, let's just create the heart widget. The heart widget will be a stack of 2 widgets, and we can those images will be images. Those widgets will be images, and you can find those images inside of the player folder. Inside, actually not here. Yeah, inside GUI, inside images. So we have empty heart. So this is the empty heart. And this is the full heart. So our heart widget is just going to be this image on top of this one. Right, so let's actually copy the relative path of this first. And let's go inside of layout, then player health bar. Cool. And here is our individual hearts, right? We're gonna be designing our heart widget here. And this will be a stack. And for the children, the first one will be our empty heart. So, the bottommost widget. It'll be an image.assets with its path. And we don't need to point to assets/images because it already looks there. And let's fix up the slash. Cool. And let's put a comma here so that everything's formatted. Now we want to add the full heart here. So let's go into the GUI. And it's just full heart.png. So we can just replace empty with full. So we'll get a stack with the empty heart image at the bottom and the full heart image at the top. Let's temporarily just go inside game layouts and then add it here. Just here, constant player health bar widget. Cool. Let's already start our game. And we get an error. Let's see that up close again. Okay, so this occurs when Flutter, is not able to actually read an image. So let's see what the issue is. Let's go inside of layout into the player health bar. And oops, so this is not the flame method of loading an image, right? So we actually have to provide in assets/images. My bad. So assets/images. Right, now it should work. Let's auto restart our game. And yeah, we do get our heart widget at the, top left. Cool. And as you can see here, there is a black border that is from the empty heart widget. So if we actually just comment this full heart, we should get a simple, the background here of the heart. So yeah, you can see this slight gray colored hearts here. Yep, now you can. And the full heart, when we have the full heart, it's just on top of that. So it gives us a border effect of it being around it. Right. First things first, let's give it some padding, the row actually. So let's wrap it around padding widget. Right. 10 should be fine. Now it should be a little bit, yeah, okay, that's better. Cool. Okay, so every time the player takes damage, what we're gonna do is we're gonna make the full heart image invisible somehow, so that what remains is the empty heart image. So if that happens, the red part will go off and then the actual black border will stay. Right, so to do that, let's first take in a parameter inside get heart widget. Let's call it bool full heart. And if it's a full heart, we want to show the full heart, which is the red part of the stack, right? But if it's not a full heart, meaning it's actually damaged, what we're gonna do is we're gonna do full heart, then do this. And if it's not, just a container. Right. And now up here, we can pass in false first. So now, since we passed false, we should just get the actual background. Yep. And if we pass true, we should get the entire thing with the red heart on top of it. Yep, we do. So now let's make it so that if the player has 3 hearts, it will only display 3 hearts and the rest 7 will be empty. So first let's just define an integer or a double called health, which we'll make 3 for now. this will eventually be the actual listenable value that our actual player's health will be, which will change or update according to if the player eats, gets damaged, etc. But for now, for testing purposes, let's just define a double health as 3. And let's change this loop up a bit. Let's initialize I as 0. And we're going to do this until I is greater than 0. And we're going to decrement I. So this is the same thing. It's going to iterate 10 number of times. But rather than starting from 1 and starting from 0 and ending at 9, we're starting from 10 and ending at 0 or at 1. So, we have the same thing, but the loop is done differently. Right. So, inside of the loop, let's define a bool value is full heart. Let's make this false by default, and then we will do is full heart. We pass it into our get heart widget function. Now, if we hot restart our game, we should get a widget but with no full hearts, right? So what we're going to do is we're going to turn is full heart to true if the actual, I is greater than or equal to the actual health. What does that actually mean? So let's first just do this. If health greater than or equal to I, then is full heart equals true. Let's hot restart our game. And we didn't exactly get anything. Let's see. Okay, not 1. Let's hot restart our game again. Right, so we get 3 hearts here. And before I actually explain what's happening here, let's go inside of here and then set the let's give a height and width to our actual stack. So we'll wrap it around a sized box, and then we'll give the width as 50 as well as the height as 52. 52, not 52. Okay, so yeah, we have everything, but let's wrap our stack around a fitted box, because our sized box is actually occupying the correct space, but the actual widgets aren't. So let's go here and then wrap the stack around a fitted box so it fills to the space of the sized box. So fitted box. Let's all restart our game. Right. But now let's quickly make this a responsive value. So double heart or just width equals media query, or let's use our game methods. Game methods dot instance dot screen size dot width. Okay, dot width. Now let's say we want everything to be 1 by 20th of the screen's width. Let's see if this works. So width and width. Okay, does this look good? And okay, no, it really doesn't. So let's change this to something like 15 or 30, something higher, so that the width will be a smaller value. And okay, yeah, that's looking good. Anyway, let's go back up here. So in the first iteration, I will be 10 and our health is 3 always, right? So we're checking if the health, which is 3, is greater than 10. Is it? It's not. So it's not going to set is full heart to true, and hence this widget is not a full heart. And then it's doing that till the 7th heart, but till the 6th heart, but when it's at the 7th heart, it's checking, or we're counting from 10 to 0, right? So I guess this would be the 3rd heart, or 0, 1, 2, so 2nd heart, like that. So if it's the 2nd heart, we're checking if the health, so 3, is greater than or equal to 2, or 1, or I, which is 3 here. So it actually sets the heart as full. So that is the logic behind this. Now let's set it to something else, like the health to 10. So now we should get a full set of hearts, and we do. Let's set this to 1. So 1 heart. Yeah, so that's working correctly. Now let's create the hunger bar, which is super similar to our actual health bar. And the hunger will indicate if the player has, the amount of food that the player has eaten. Okay, so let's create the file for our player hunger bar. The player hunger bar dot. And of course, it'll be inside of a layout. Then this will be a stateless widget, as always. Call it player, not hunger bar widget, right? And here we will return everything that we're returning inside of the player health bar, because it'll be super similar to that. The only difference will be the actual widget here, or the actual image, right? So let's copy everything inside of a widget build function, and let's paste it inside here. Now we need to import all of this. So padding from material, and we also need our function get heart widget. So inside here, let's copy that too, and let's paste it here, right? And we also need to import game methods. And okay, so inside of our stack, we have 2 images. One is the background and one is the foreground. Okay, I had an absolute stroke there. Anyway, so this is the foreground. So the background is the dark part of our widget. So, it'll show when we don't exactly have a full health or a full hunger. So that'll be the background. So here in our case, it's the empty heart, and then our foreground, which will show when we have sufficient health or hunger based on a certain value, is our foreground. So in our case, it is this red part of the heart here. So the background for our hunger bar will actually be inside GUI. We have an image called empty hunger. So this one will be the actual background for this widget. So our hunger bar, and then the foreground will be this one, full hunger.png. Right, so let's simply replace that inside of our player hunger bar. So this will be empty hunger instead of empty health, and this will be full hunger instead of full health. And let's test this out by going inside game layout, and then let's first uncomment player health bar, and let's add in the player hunger bar widget. Cool. Now let's restart our game. And yeah, so we have our hunger bar, right? And to just prove it to you that it works, we can go up here, change the health to like something like 7, and we should get 7 hunger bars or 7 hunger points. And yep, we do. And of course, the terminology here is completely different, because we should call this hunger instead of health, and then is full hunger instead of is full heart or whatever. But I'll just keep it like this for now for simplicity. But you guys can change it if you really want the best readability for your code, right? And the entire reason why I actually uncommented player health bar is because these both will actually stack. Yeah, because this is a stack, and then these both have the same position inside of the stack. So obviously one is going to be on top of the other. So to overcome this, we could either give some kind of padding, a higher padding to our hunger bar, or we could create an entirely new widget, let's say called hunger and health bar combined. And inside that, we'll have a column with both of these, and then we will add our combined that widget inside of game layout instead of adding these individually. So let's do exactly that. So inside of layout, let's call this combined column as hunger and health bar dot dot. And this will be a stateless widget. Doesn't really matter. Hunger and health bar. And we'll be returning a column. So we need the health hunger bar under the health bar. So yeah, and health bar, player health bar widget, and the player hunger bar widget. It's that simple. Now let's go inside of our game layout and delete this, and then add a hunger and health bar instead. Let's not restart our game. And yeah, we get these two under each other. Right, that is cool. But we get some weird vertical padding. This is because in both our player health bar and hunger bar, we are returning the row with a padding widget. So let's first remove the entire padding widget. So now for the hunger bar. Right, now let's all restart our game. So okay, now we get both of those bars without the actual padding. But we actually do want padding to the left and top of these two combined. So that is inside of our health and hunger bar column, and we can simply give that same padding to the column. So yeah, now let's not restart our game. Yeah, cool. So that looks really good. And now finally, let's remove the player health bar and hunger bar from our layout, because we already have a combined version of it inside health and hunger bar. So we don't really need it here. So let's just transfer it inside widgets. Move and move. Right. Now let's all restart our game. If if that didn't automatically refactor for you guys, you might have to remove the import and then import it again. But yeah, cool, that's okay. We need to link our health bar to the health of the player. So we need to actually implement the concept of health first. Health basically just defines the amount of damage the player will be able to take before dying. The health will slowly increase if the hunger bar is full. Health will be something in common to all entities in our game, and not just the player. Like a zombie or a spider should also have a health. So we'll add this to our entity class. We'll subtract from health if damage is to be done, and add to health if we want to heal. But at the same time, we should make sure that the health doesn't go below 0 when decreasing and above 10 when increasing. Okay, so let's go inside entity dot dot inside resources, which contains our entity class. And here, just like all of these properties here, we'll add another one, which will be a double health, and we'll start it off as 10. Now, the whole point of health is just to determine when the player will actually die. Like if the health turns into 0, we want to kill the player or remove it from our component tree. So let's first add the logic for that. So we'll create a new function called void kill player, and or we'll just call it not a player. This is inside the entity class, so we cannot exactly assume it's just going to be for the player. So we'll call it kill entity logic. Right. So here, stuff will be pretty simple. We'll check if the health is 0. If the health is 0, just kill the player. So remove from parent. So remove from parent just removes this component from the component tree. Now, we'll never reach health equal to 0. Now, because, we haven't really implemented any logic to actually change the health. So let's do that. Let's go here and then add a new function called change health to And then this will accept a double again. So double new health or whatever. Right. And okay, this kind of implies that we're changing the health to an entirely new value. Like we're setting health equals 9 like that. But we want this, the function of this function to actually just change the health. Like if we do change health and do -2, it's going to actually take away 2 hearts from the health. We want it to be like that. So we'll change it to change health by, and then we'll take in you know, okay, let's just call it value. So now it's way more readable, right? So what we cannot exactly simply do health plus value. This would certainly work, like if we were changing, doing change health by, and let's say the current health was 5, and then we put in 2 here, it would change into 7. The health would change into 7. And if we put -2, it would change into 3. But let's say the health was like 2, and for some reason maybe a zombie attacked our player, or we fell down really far and we're taking fall damage. We're doing like -5 or something. We want to take away 5 hearts. But if we do that with this logic, it's going to be health plus, or in our case health is 2, so health plus -5. That would change our health to -3, right? But we do not want our health to go down to such values. We want, if we are subtracting something super high from our health, we want it to cap at 0. And same when we are healing. Let's say the player's current health was 9, and the player ate something like a food item that caused the player health to go up to maybe like 5. So you ate maybe something super good. So we've programmatically defined that if that item is eaten, we want to change the health by 5. So this would make it be 14, but we do not want that either. We want it to cap at 10. So let's add the logic for that. Let's remove these comments here and here. So we'll first check if the current health plus value. So this will give us what the value will be once actually the health will be once we add it to our value. So we first want to check if this is smaller than or equal to 10, right? So we're not like adding, it won't go about 10 if anything inside here. So but if it's not smaller than or equal to 10, meaning it's greater than 10, like let's say the current health was 7, and then we are adding it to 10 or something like that, it's going to be 17. So this condition won't satisfy. So health plus value not equal, not smaller than or equal to 10. So it'll go inside the else, and inside the else, if such a condition happens, we don't want it to change it to 17. But we don't, we could like simply do this. So this would mean that if we ate an item that gave us 10 hearts, or ate a food item that gave us 10 hearts, and we were at 7 hearts, this condition wouldn't satisfy, and then we won't gain hearts at all. But we do not want that. So we'll put an else here and then check if it'll eventually be greater than 10. Then we'll just set it to 10. We'll set the health to 10. So if we were adding like 10 to 7, the health will just increase by 3, or it'll just cap at 7, right? And we'll do a similar thing here. We'll check if, okay, now we know that the eventual health will be smaller than or equal to 10. If yes, we're going to check if the eventual health again is greater than or equal to 0. Because let's say our current health was 4, and then like multiple zombies attacked us, which caused our program to tell us to take away like 6 hearts. So if yes, it's gonna go here. So health plus value, we're gonna do greater than or equal to 0, right? And we put an else here. So if this happens, so health plus value will be -2. This won't satisfy. So -2 not greater than or equal to 0. So it'll go inside this else. So here, just as we did for health equals 0, we'll do health equals 10, we'll do health equals 0. So if we, were to do something like this, it wouldn't like take us to -2, but it'll just take us to 0, right? And inside here, we'll just do health equals or health plus equals value, same as doing health equals health plus value. So this is our foolproof function to actually change our health. Now let's go inside of our player component, and inside the void update, let's just print something. Print player health is, and then we'll put colon, and then we actually want to print the health. So since we're extending from entity, we have access to health. So we'll put a $sign and then do health. Right. Let's not restart our game. And we should get constant tens. So let's see. So 10, yeah, it's printing multiple times. Right. So that is our health. And now let's actually put some logic here that will take away our health. So we'll do change health by, and then we'll put -1. So what will happen now is that each frame, it's going to take away 1 heart of our health. So it'll go from 10 to 9 to 8, 7, then eventually 0. So we're just doing this to see if a function actually works. So 10, 9, 8, 7, 6, 5, 2, 1, 0. And as you can see here, it doesn't go below 0. That is because of our fail-proof logic that we just implemented. And, we'll check if, okay, in the onload, let's temporarily go into our entity dot and then change the health to 0. So it starts off at 0. And let's go to our player component and then do health or change health by, and then 1. So doing 1 is the same as doing +1. So we're just adding 1 to the health. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it caps at 10. It doesn't go above 10. Right. Cool. But another problem. Let's actually revert this back to -1 and go into entity and set this to 10. If we hit 0, we're not exactly dying. That is because inside of the on update of okay, we have our player right here. Ignore the actual GUI health bar because this is not exactly linked to the entity health, but we'll eventually link it. But when we are hitting 0, the player is not dying. So let's change that. We can simply fix this by going inside of our player component here, and then in our set of logics, we'll just do kill entity logic. Right, it's that easy. So the kill entity logic simply checks if the health is 0. If it is 0, it's just going to kill the player. So we can't see a player actually. That is because our player died. Let's look at that again. So yeah, a player disappeared because our health hit 0. Right. So now we can use our kill entity logic accordingly for different entities. Like for example, we can, we won't implement this for our item component because, our item component is also an entity. But as long as we don't actually add the kill entity logic inside the void update, it won't actually, die or something like that. So now let's add fall damage. Fall damage is just the damage that will be done to the player when a player falls over a specific number of blocks. For example, if the player falls over 10 blocks, let's say if we build up 10 blocks and then fell, we want to do 5 hearts of damage. And if the player fell through 8 blocks, we want to do 4 hearts of damage. So half of the number of blocks fallen. So yeah. So this fall damage will be something in common to all entities. So we'll implement that inside entities. So let's go inside entities by holding control and then hovering over entity and then clicking on it, right? And an integral part of actually calculating the fall damage would be the blocks that has been fallen. Like we know the equation. Like we want to do half of the blocks that has been fallen damage to the player, right? So we need to keep track of how many blocks has been fallen. So let's create an integer or a double and we'll call it blocks fallen and we'll set it to 0 at the first. And now let's go inside of the falling logic because here is where most of the falling happens, right? And let's fix this up a little bit because, okay, in this logic, we have two different common statements. So regardless of what the outcome of the condition is, it's executing position.y plus equals y velocity regardless, right? So we'll do something else. We'll remove position.y plus equals y velocity. We'll cut this out and then remove this and add this after these conditions. So this is the same as what we were just doing, but it's more cleaner and yeah, this is the better way to do it. Right, cool. And we can remove these, this else statement. So this y velocity is the number of pixels that the player is falling in a particular frame, right? So we could simply do blocks fallen plus equals y velocity. Yeah, that's it. Now let's go inside of our on collision to ground collision. And then here, every time the player touches the ground, we want to set our ground collision to 0 or our blocks fallen to 0, right? Like just as we are doing for y velocity, we have to set the blocks fallen to 0 because when the player falls again, it's going to start from 0, right? Okay, and then here let's also print blocks fallen. Okay, let's make this a string and then put a dollar sign here. So blocks fallen pixels fallen or something like that. Let's hot restart our game. Let's go inside the debug console. And okay, so first things first, let's go inside of our player component and then remove this logic that just kills a player. So let's remove this. Right, now let's see, let's hot restart our game and go inside the debug console. Okay, so we just fell. So it said 269.3 something something pixels fallen. And of course, this is in pixels and not blocks. So to actually fix that, we can, it's fairly simple. Let's go inside entity again. And then inside of the falling logic, here we'll just divide this y velocity by the blocks fallen. So the blocks fallen will actually be in blocks and not exactly pixels. So to get the block size, we can do keymethods.instance.block size. And we can do .x because it's a vector too. Now let's see the same thing happening. Okay, the player fell. And then, okay, it says 0 pixels fallen. Okay, no, here it says 4.127935 something pixels fallen. So that's exactly one block. And let's, okay, ignore the keyword pixels because we just put that in a string, right? It's actually blocks. And now let's fall some more. So that was almost a block. But okay, 2 blocks. So 2 blocks fallen. Right, so now we have an accurate way of actually measuring how much the player has fallen. So now we can actually do our fall damage. But we don't want to do a fall damage when the player's just, walking like this. We want to do the fall damage. Ooh, diamonds. Okay, anyways, we want to do the fall damage when the player's actually jumping from a super high height. Like right now we have 1 block fallen, 1 block, 0.9 blocks fallen or whatever. But let's say the player like built up somewhere and then fell. Only then we want to do fall damage. So we'll only do fall damage if the blocks fallen is greater than 3. So let's go inside of a ground collision. So we'll be doing a fall damage here when the player actually hits the ground. That is, of course, where the collision happens, right? So we'll put an if statement here. And then we'll check if the blocks fallen is greater than 3 or greater than 3. And if yes, we're gonna print doing fall damage. Right, let's sort restart our game. Let's go inside the debug console. And with our gold shovel, let's actually pick up some sand that we can build up. Okay, now let's place these down. Oops. Okay, so we are at a fairly high height. Now let's fall. And it says doing fall damage. Cool, so it only happens when we are falling from a high height. So now let's just try jumping. And let's see if that fired, and it didn't. These two print statements just happened when we actually fell that time. Right. So now our logic inside, actually doing the fall damage, we want to do, let's say if the player fell 8 blocks, we want to do 4 hearts of damage. So that's quite easy. We'll just do change health by, and okay, now the player, the entity, of course. And sometimes I'll be referring to the damage done to a player and not to an entity. So yeah, just get used to that. Sorry. So okay, here we'll do blocks fallen divided by 2. And this is a positive value, meaning it'll get added, right? So if we fell like 2 blocks, what's gonna do? Okay, maybe if we fell 4 blocks, it's gonna just add 2 hearts, right? But we want to take away 2 hearts, so we'll do negative. Let's auto restart our game. Okay, let's go into the debug console, and okay, we fell, and okay, I guess that wasn't a high enough jump for fall damage. So let's pick up some grass. Cool. Let's place this down. Okay, now let's jump off this. And okay, we didn't get anything this time. Let's see. Okay, so that is because we're not exactly printing our health. So let's go inside player, and then let's print the health of the player. Oops. Right, let's hot restart a game and try that again. Okay, golden shawl. Right, I think that's enough blocks. Let's go up this. Oops. Okay, now let's fall again. And now inside our debug console. Okay, so we went from 10 hearts to 7.7 hearts. Cool, so that is fall damage done. And to actually test if the player will actually die, let's first go inside main game and into the area where we are giving the player some stuff. So here, let's do world data. Okay, let's duplicate this down, shift alt and down arrow key. And then let's give the player some blocks. So blocks dot birch leaf. Okay, maybe not birch leaf, because that's not playable. We'll give stone or something. And let's duplicate this down, shift alt down arrow key. Okay, let's auto restart a game. Right, so the player has 20 stone now. Let's just keep putting this higher and higher till we reach our build height limit. And I guess we did. Now let's jump off. And let's see how much health we're at. And we're actually at 1 heart. Now, if we try a little bit more, we should be able to die. And yes, since the health actually reached 0, the player died. Cool, so that is fall damage working. Now let's link the player health bar to the actual entity health. So if we fall down, the actual widget also changes the value. So the health of a player will be specific to each world. For example, you can have world A with a player with 9 hearts of health and world B with just 3 hearts of health. So we'll add this to our world data. So let's go inside global to world data. And we already have a class specific for all of the player data, right? So let's do this inside player data, and that's already inside of world data, so it's global. And we can add the health here. So let's do that. So this will be an observable, so Rx, and the core value or the data will be double. So double, and we actually have to import Rx from get, and we'll just call it player hunger. And it's we'll default this to 10, right? And this has to be 10.0.obs because it thinks that 10 was an integer, so it doesn't match the type double, right? And now let's go inside of our actual widget. So let's go inside widgets, then our player health bar, and here we'll remove this health and then wrap this entire thing, our row that is, around an obx. So an obx updates every time a value inside of it changes. So obx, actually an observable value inside of it changes, and we'll use a curly braces this time and then just return the row, right? And but right now we'll get an error because we're not exactly using an observable widget or an observable value inside obx, that it will listen for changes and then update. So we'll first let's cut all of this out and then paste this inside here, and this health will be replaced with our observable widget or our observable value, sorry. So to get the observable value, we'll use the global game reference dot instance, then our world data, and it's inside player data, and it's the player hunger. I think I meant to name that health, so let's change it to health, right? And let's go inside here again, and it's player health, and this will be dot value, right? Because we need the actual value. So that is it. Let's auto restart our game. And yeah, now we have a full 10 hearts, right? This is because we defaulted the value of our player health inside player data to 10. But now if we like fall, let's try falling. Let's build up. And oops. Let's place some blocks here. More blocks. And let's fall. And nothing happens because our player health is not linked to the entity health. So let's go inside of our main game, or not a main game, inside of the play component, and then we want to actually link this health, which is our entity health, into the actual observable value, right? So let's do that, and let's first get our actual player health. So global game reference dot instance dot game reference dot player component, okay, not world data dot player data dot player health. And now this is something that's like super annoying to type, so we'll do first dot value, and then let's assign this to something like integer, or okay, double player health equals that, right? And now we'll just check if the player health does not exactly match with the entity health. We'll set the player health to the entity health. So player health equals entity health, right? So let's say at the beginning the player health is always like 10, and if let's say in the beginning we fall right to the ground, and the entity health is going to be set to like 7 or something. So if yes, this condition will not satisfy. Actually, this is not equal to health. So this condition will satisfy because 10 won't be equal to 7. So if yes, the actual player health will be set to health. So let's see if this works. Let's auto restart our game. And okay, let's try building up. And now let's fall. But again, the value doesn't exactly change. So let's actually try copying this and then doing this, because we were actually changing a copy of that actual observable value and not the exact observable value, right? Okay, so the actual health just changed. So we're at 10 right now and we fell. So now it's at 7. Cool. So it's actually working. Let's fall a bit more actually. Let's select our stone and let's build up. Right? Now let's fall. And yeah, we have 3 more hearts. And if we go up 6 blocks, we should actually reach 0 hearts and eventually die. Let's see if that's the case. Right, so we reached 0 hearts and the player disappeared. Cool, so it's actually linked. And now let's also link our hunger to our value. So let's go inside of our play component again. Okay, not a play component, our player data class. So let's go inside global, then player data. Right here, just like player health, we'll have player hunger, player hunger, and we'll set this to, we'll do the same thing that we did for our our player health bar. We'll turn it into an observable and then change the actual value to the value inside player data. So let's actually copy this and then go inside player hunger bar. Let's wrap our row around a widget. Actually, not that. We'll actually cut this and do obx, import this, and we'll return the row. And we'll put everything inside here, inside this obx, so that all of these logic happens again when it reloads, right? And now for 7, we'll put in global game reference dot instance dot game reference dot world data dot player data dot player hunger dot value. Right, now let's restart our game. And yeah, so the hunger is also at 10, right? Now let's make it so that the health regenerates when the hunger is about 10, or when there's full hunger, and then over some period of time the hunger will also go down. Okay, so now we want to make it so that when the hunger is full, we want the player to slowly regenerate, and also make it so that after a period of time the hunger slowly goes down, right? So let's go inside of our play component. And let's put all of these functions inside of a function called health and hunger logic, right? Let's call this from a void update just in case we won't get it, right? Okay, so here we'll first check if the hunger is okay, so we first need the hunger of the player. So to get that, we're going to copy all of this, we'll play data, and then do dot player hunger dot value. We're going to check if it's greater than 9. It's the same thing as doing if the value equals 10. But then sometimes when maybe we're doing maybe we're changing the hunger by a small value over a period of time. Let's say okay, so our hunger in the beginning is 10.0. Okay, and maybe we walked for some time that caused the hunger to be 9.99 or something like that. If yes, 9.99 would, result to be, to being the health bar still being full, right? Even if it was 9.99, the health bar would still be full. So, we don't want to make it so that the player does not regen over that period of time. So we're checking if it's greater than 9 rather than if it's exactly 10, right? So this is a good way of actually checking the logic for doubles. So if it's greater than 9, slowly regen the player. So we're going to do global game reference dot instance dot game reference dot world data dot player data dot player health. And actually we can use the change health by value function, and then we can pass in something like, let's say, 0.01, right? So let's auto restart a game. So it changes it by a small value. It's okay. So we got a little bit of damage. And yeah, so as you can see, we're slowly healing. Right. So let's see if that goes up again. And it does. Right, so that's good enough. But let's actually make it 0.05 so it heals a little bit faster. So, if we did 1 here, each frame, it would go up by 1. So, like, it'll be super fast. So, I'm going to show you exactly what's happening. So, right, so you didn't even see what happened because we're, it's happening super fast. But when we're doing 0.1, what's happening is each 10 frames, so every 10 frames, this will add up to 1 heart, right? So let's auto restart a game. So it'll happen slower. So each 10 frames is gonna go up 1 heart, and just like that. But I think that's way too quick too. So I'm gonna do 0.05. Let's see. And yeah, that's good enough. But let's make it 0.75, so it's a little bit faster. Right, cool. So now we have the regeneration logic. Right, this is fine. Now we also want to add, we also want to make it so that over a period of time, the hunger slowly decreases. Like, if we, if the hunger never disappeared, like went down a little bit, we'd have infinite health, right? If we just took damage, we would regen back again. So we want to make sure that the hunger slowly decreases down over a period of time. So just like this, we can do health and hunger logic. We can do change. Okay, so we need the hunger. So we'll do global game reference dot instance dot game reference dot world data dot player data dot hunger, and then we can just do value minus minus. Okay, let's see what this does. If we are just decrementing the value, so minus minus is same as doing minus equals 1. So each frame the hunger goes down so much, right? But one thing is that let's just print the value here every loop. So if we print the value of the hunger and go into the debug console, let's see what happens. Okay, it's going down and then it's reaching negative values, because unlike our health inside entity, we didn't really add fail proof logic for this. So let's actually copy all of this, and then let's go inside of our player data or our player component, and we'll add this function here, and then we'll change it to change hunger by. And the only thing we're going to be changing here is, okay, we first need the okay, we'll change the health here to hunger, and yeah, and then to actually get the hunger, we're going to do double hunger equals global game reference dot instance dot world data, dot game reference dot world data dot player hunger dot value. So we have the hunger, and we're gonna add this to the actual value instead of the hunger, because then only it will actually update. So we'll change health everywhere here to the actual hunger value. Right. And so here, what we can simply do now is we'll remove the minus minus, and then we'll do change hunger by, and then we're going to give 0.1. So now let's see what happens. It's okay. It actually control Z everything till we have a print statement again, right? And let's do change hunger by and minus, okay, not health, change hunger by, right? Let's see what happens now. So 9876543 and okay, 0. So the hunger does not go below 0, right? So this will avoid some bugs in our game. So what's exactly happening? We just copied all of the fail proof logic. So we got the current hunger. This is the current hunger. And we're checking if it added to the new hunger will be greater than 10. If it's greater than 10, we don't want to go above 10. So we're just setting the actual value to 10. We cannot set the hunger to 10 because this is just a copy of the actual value. So if we update hunger, it won't exactly update our hunger bar. That's why we are doing all of this stuff to actually change the value. And then we're checking if the current hunger plus that value is greater than 0. If not, we're setting it to 0 because we don't want to go below 0. And if it's greater than 0, we're just adding it, right? So it's that simple. And we don't really want our hunger to go down that fast. So one way of making it going down like super slow is just doing 0.00, okay, 0.001 or something. So it happens like super slow. Let's just put it as 0.05 for now. So let's see what happens. Right, the hunger is slowly going down. This is fine. But we have a few problems here. We're doing this each frame of our app, right? Let's say we were running at 60 FPS. That would mean that this widget will be updating. Okay, so when we're actually changing the value of player hunger, what's happening is that inside widgets, inside of the player hunger bar, it's reloading all of this over and over again, right? So that's gonna cause so many lag in our game. So we don't really want to do it like that. So let's go inside of our play component again, and then rather than changing the value by a small amount each second or each frame of our app, we're gonna implement some kind of timer. So let's say the timer in 20 seconds, we've set the timer to be to run at 20 seconds. So every 20 seconds it's going to change the hunger by, let's say, -1, right? So this would mean that it doesn't update the hunger bar widget like every 60th time in a second, right? So how do you actually add a timer? We can, it's actually quite simple. Let's go up here, and yeah, just as we did for here, to set the refresh speed, we can add another timer. Let's duplicate this down, Shift Alt and the down arrow key. And we want the period to be, let's say, 20 seconds. But for now, let's put 5 seconds just for debugging purposes. And each 5 seconds, what we want to do, we want to change the hunger to a smaller value. So change hunger by -1, right? Let's all restart our game. Now, let's see. Yeah, so every 5 seconds, the hunger is going down. So now this is a better way of doing it since the widget doesn't constantly update, and then, that doesn't cause errors in our app or something, right? It wouldn't exactly cause errors, but it would certainly be laggier. Okay, and we'll change this from 5 to maybe like 25 or 30. So it only happens over a long period of time. Right. Now let's add food items to our game. A food item would just be another item with a new property called isEatable set to true. And if you have that food item selected in your inventory and you click on the screen, it's going to add a few hunger points to your hunger bar. And eventually it's going to regenerate your health. Okay, so let's go inside items dot dot inside resources, and let's create the new property final bool, and this boolean will be called is eatable. So all of the items that are going to be eatable will have this property as true. So let's default this to false, and oops, and let's go down to cases here, and then we'll add a new case items dot apple. So if it's an apple, we want to return an item data with the is eatable as true. Right. Now the whole reason why we are actually creating a property called is eatable is so that inside main game, let's go here and into the place block logic, place, okay, yeah, inside here we can either check if the current held item is eatable. If it's an eatable, then don't place a block, rather eat the item. But if it's not an eatable, then you're just go ahead and place the block or something. So we'll put an if statement here. We'll check if the let's actually just undo all of this. It'll only place block if it's an actual block, right? So we can ignore this, and then we'll put an if statement, and then we'll check if the current held item is an eatable. So we got to check if the to get the current held item, let's copy all of this and let's paste it here. This points to the current held item. We're going to check if it's an item first, and if it's an item, we also want to check if it's an eatable. So let's actually create a new function called void eating logic, and we'll cut this if statement from here, and then we'll put this inside eating logic so that our on tap down doesn't get too crowded, and let's place this here, right? And then let's actually, we don't really want to type all this out every time we want to check for the current held item, right? So we're gonna like just do dynamic current item equals this. So now we just need to check if dynamic or the current item is item, and it's dynamic because it can either be a block or an item. So we're first checking if it's an item, and if it's an item, we want to check if the item data dot get item data for current item dot eatable. So we want to check if it's an eatable. We don't really need to do equals true. We can just check if is eatable because it's already a boolean. So if that is, we want to change the hunger to some value. Like if it's an apple, let's say we just want to change it by 2 hunger points or 2 hunger bars. But let's say, eventually maybe we'll add more complex food items like steak or a golden apple, for which we'd want different hunger points, right, when eaten. So we'll put all of those inside of a file called foods dot dot inside resources, and then the only thing we'll have here is a simple map, and this map will take in an item and then it'll return, oops, let's import items, and it'll return a double, okay, and we're gonna call it get food points for food, and here we're just gonna do blocks dot apple. So if it's a blocks, okay, not a blocks dot apple, and items dot apple, my bad, if it's an apple, then change it by 2 hearts or something like that, right? Now let's not 2 hearts, 2 hunger points, right? So now let's go inside main game, and then here we're simply gonna do, okay, we're gonna do player data or player component dot change health by or change hunger by, and then we can change the hunger. Okay, we're able to do dot change hunger by because inside of the player data we are inheriting from okay, not here, inside the player component, actually, my bad. So the component we are inheriting from entity which has that method, so we are able to use that as a method inside our main game. So that's super convenient. And change hunger by, we can do get food points for food, and we're gonna pass in the current item. And we gotta put an exclamation mark here, because maybe what if we pass in something that does not exist there? Maybe we added an extra food item, but we didn't create a food points dot food for it. Like, let's say we added a golden apple, but we didn't do item dot apple for it. So in that case, let's do something. Let's go inside main game, and here inside eating logic, yeah, we won't put a null check because maybe it could be null. So we're going to put 2 question marks and check. If it is null, then don't change the hunger. So just we're changing the hunger by 0, right? So that is what the question mark operator does. If it's not null, it's gonna do whatever this value is, but if it is null, it's not gonna do anything, right? And after an item is eaten, or after a food item is eaten, we want to decrement what has been eaten, right? So let's copy all of this, and we're gonna do dot decrement slot. Okay, now let's go inside our onload and then give the player a bunch of apples. So let's change this to items dot apple. Let's duplicate this down, right? Let's hot restart our game. Okay, so yeah, we have 7 here, but let's quickly go up to our player component and all the way down to health and hunger logic. Actually, up here into the timer, and where's the timer again? Right here. We'll change this to like 5 real quick so that the hunger goes down quicker, or let's change this to 2 even, so it's even quicker, right? So we're healing, but we're not healing anymore, and the hunger is going down. So now if we select an apple and then click on it, yep, the hunger goes up. And then if we click on it twice and the hunger is full, it starts regenerating, right? So let's go over everything that we just did. Inside items, we created a new property called eatable, which we set true for all of the blocks that we want to eat. Sorry, all of the items that we want to eat. And inside main game, when we are actually clicking on the screen, inside on tap down, we're also entering a thing called eating logic. Inside the eating logic, we're checking if the current held item is an item and it is eatable. So we're using the is eatable property here. So if it is eatable, we're just changing the hunger by the actual points that we want to change for that particular eatable. And we also created this map which just returns the food points for each food, right? So maybe if we in the future, maybe if we wanted to change the hunger for apples from 2 to 1, we could just change it here. So every time you eat an apple, it'll only change the health by 1, right? And finally, let's go inside player component again and then change this timer back to 25. Right, that's it. Now let's make it so that the player speed decreases when the hunger is below 3. And if you eat it and you get the hunger points above 3, you get your normal play speed. Right. First things first, let's fix a bug where if you just click an item, okay, let's say I have a diamond shell in my inventory, and if I click somewhere, it just disappears. This is because in our eating logic, we are decrementing the slot outside of the if statement. So let's put this inside here. So what's happening is every time we click, it's going inside eating logic. And then, if it's an eatable, it's going to do its logic. And then we have this outside of this if statement, meaning every time you click, it would decrement the current slot. But right now, that should be fixed. Let's see. I'm going to click somewhere. And yeah, that doesn't happen. Right, cool. Now let's go inside of our player component. Here. And down here. So here's the main area where we are actually changing our speed. So here we can check if the current hunger is greater than 3. If it is greater than 3, we can do our normal logic. But if it's like smaller than 3 or smaller than or equal to 3, we're gonna, make our player speed a little bit slower. So we're gonna put an if statement here. And to get the actual hunger, let's create a variable here. Double hunger equals game methods dot instance dot okay, not game methods, global game reference dot instance dot game reference dot world data dot a player data dot player hunger dot value. So this gives us the current player hunger, and we'll put this inside of our if statement actually, so that it doesn't check for this each each frame of a game. And here we'll check if the hunger is greater than 3. So if it is, then do the normal stuff, which is what we had right here. But if it's not, what we're gonna do is we're gonna copy paste the same thing down, but we're gonna do player speed divided by 2 into whatever this is. So it's just twice as slower, or we could just divide the whole thing by 2. So we can just do local player speed equals local player speed divided by 2, and that's the same thing as doing local player speed divided by equal to 2, right? And this should be it. Let's hot restart our game, and it's actually go inside of the timer here and then set this back to like 3 or something, or I guess 2 is fine, so that it happens like super fast. So we can debug this real quick, and let's see. Okay, we are moving at the normal speed, right? Let's see. And okay, now we are at 3 hunger points, and yeah, now we are super slow, right? Now let's eat something, and let's eat a bit more. And yeah, okay, we're back to our normal speed, right? So let's see this in action again, and yeah, so now our speed is back to being super low. All right, cool. Now let's make it so that when you mine a birch leaf, there would be a 50% chance of getting an apple rather than a birch leaf. And when you mine a stone block, you'd get a cobblestone rather than a stone. And this is because for all of the recipes for crafting stone tools, we'd be using cobblestone. So let's open up our crafting table here. And as you can see, it takes in a cobblestone rather than a stone, right? Okay, so to do this, let's go inside of our block component, and we will create a new property called item dropped. Now this will be of type dynamic. So let's define this. Dynamic item dropped, and this can be null, right? So what we're going to do is, for specific blocks where we want a different block or an item to drop that is not its original parent or its original block, we're going to be setting the item dropped to what we want that new block to be. Like for example, let's say we want a birch leaf to drop an apple. So for that to happen, what we're going to do is we're going to set the item dropped of a birch leaf to an apple, right? So that's what's gonna happen. So let's go inside the unbroken, and inside the unbroken is where we are actually creating the item component when the block is broken, right? So the item is block, but what we're gonna do is we're gonna not exactly delete block, but we're gonna add item dropped and then question mark. And now, as we know, the question mark operator makes it so that if a variable is null, it's going to change the value of this to what's at the right of it. But if it's not null, the actual value is going to be item dropped. For example, let's say for we don't, we're not going to be setting an item dropped for grass. So the value of item dropped will be null. So if it's null, it's going to go to block. So it's just going to create a normal block component for it, or a normal item component for it. But in our case, for the birch leaf or stone, we're going to set an item dropped, so it won't be null. So when it's not null, it's going to create an item component with the item as the item dropped. So let's see this in action. Let's go inside the crafting table, and then we'll set the item dropped of the crafting table to something. So let's go down here, and then let's go into the onload. So the onload is type of future void onload, and this will be asynchronous. We also need to call super.onload, of course. And then here we'll set the item dropped of this to maybe we'll set it to bedrock, right? Something very distinctive. Now let's restart our game. And let's quickly go into the main game, into the onload, where we're giving the player a bunch of stuff. Let's give the player a crafting table, right? So that we don't, we won't have to craft it. Cool. So let's see. And yeah, we spawn with the crafting table. Now let's place this and let's break this. Oops. To break it, we need to actually have another item inside the inventory. Cool. So yeah, we got a bedrock. So what happened again? When at each instance of crafting manager, or not crafting manager, or in each instance of crafting table block, we're setting the item dropped to bedrock. So inside of our block component, it's checking when the block is broken, and when it's actually going to create an item component for it, it's checking if the item dropped has some value. If it has a value, it's going to create the item component for it. And if it doesn't have a value, it's just going to create a normal component for it. Yeah. And we're actually getting this instance by inside of our blocks.dart, inside of this factory function, or this normal function that just returns the parent for a block, right? So for every crafting table, we're not returning a simple block component for it, but we're returning the instance of this class that we created, right? So what we're going to do is we're going to be creating a class just like this for our blocks where we want different drops. So let's do that. Let's go inside of blocks, and then let's create a birch leaf file. So birch leaf block.dart, and everything will be quite straightforward. We'll simply create a class for this birch leaf, the birch leaf block, and then we have to extend it from block component so that we get all of the functions and properties of block component. Now we get an error. That is because we need to call the constructor of birch leaf block, and then actually require all of the parameters and values. So just like in a crafting table, we want to require super.chunkindex and super.blockindex, and give the block as whatever the block is. So in our case, birch leaf. So let's require the super.chunkindex and blockindex. So require super.blockindex and super.chunkindex. And we also need to set the block to a birch leaf, of course. So birch leaf, and we have to import blocks. Right, and we gotta require this. Yep, and that's it. And here inside the onload, let's actually go inside the crafting table block, and then cut this and paste it here. And we'll set the item drop to blocks, actually items dot apple. So every time a leaf is broken, it's going to drop an apple. Now let's all restart our game. And okay, let's actually restart it again so that we get a birch forest spawn, so it's easier to find a leaf. And I guess we're super unlucky. Right, I guess we just have to go and find one. Okay, there. Okay, I found one. Oops, gotta eat some apples. And actually, yeah, for debugging purposes, we are actually set the timer for changing our hunger, for depleting our hunger to 2 inside of our play component. So let's change that back to 25. Okay. Now the hunger should, change only every 25 seconds. So I'm gonna just get a birch forest spawn. Yep, we did. Cool. Now let's break this. And okay, we're only getting leaves. That is because we actually didn't add this to our parent. So let's go inside blocks.dot, inside the get parent for block. And then here, every time we are adding a block component to our game, not a block component, any block to our game, we are adding the get parent for block actually. And this will return a block component if there are no cases for this. But for specific blocks such as crafting table, it's returning the new class with a specific functionality that we created. So here we're gonna check for the case of blocks dot birch leaf, and if it's a birch leaf, we are simply going to return our birch leaf block. Right, and let's hot restart our game. Now everything should be working, and I hope we get a birch leaf spawn, birch forest spawn this time, and we don't. Let's try it till we do. And yep, let's try breaking this, and yes, it does drop an apple. Cool. But we have one slight problem. We have completely removed birch leaves from our game, right? So now we have no way of actually getting a birch leaf. So what do we do? So inside of a block here, birch leaf block, we can make it so that it only, we'll put some random value. So there'll only be a chance of it dropping an apple. So how do we actually get this? Just a chance of it. So we can put an if statement and then use the random class, the random dot a next bool. Okay, so the next bool either returns true or false, right? As we know. So here inside the next bool, we can put this here. So if it is true, it's going to set the item dropped to an apple. And if it is false, it's not going to set it to anything. So the item dropped will be null, and then it'll create an item component just for the normal block. So a birch leaf. Right, let's see how this goes. Okay, let's try breaking this. Yep, we got an apple that time. And again. And yeah, this time we got a birch leaf. So there's a 50% chance of it either dropping an apple or a birch leaf. Cool. Now let's do the same thing for our stone. So currently when we mine stone, we get just the stone block as it is, but we actually want a cobblestone to drop. So we're gonna create a new class for it. So let's call it stone block dot, and let's create the class stone block. This is going to extend from block component, and inside the constructor, we're gonna have to require everything. So super, required super dot block index and required super dot chunk index, and then we just set the block of it to stone block, right? So super, and then we set the block to blocks dot stone. We need to import blocks first. Right, so now we have gotten just another normal class. So let's add this to a blocks.dot first so that we don't forget it later. Case, if it's blocks.stone, don't return a simple block component for it, but return the new class that I made for it with a specific functionality. Right, now let's go inside of our stone block again, and we'll create an onload for it. And I don't really want to type all of that code again, so I'm gonna just copy it from the birch leaf block, and then I paste it here. And I'll set the item dropped to blocks dot cobblestone. Right. And now inside of the main game, let's actually give the player a pickaxe so that we can mine it. So items dot gold pickaxe, the best pickaxe in the game. Right. Okay, our game has loaded. Now let's go mine some stone. Okay, so let's fix up our inventory up a bit. Right. And now let's mine this. And yes, so we get our new block, cobblestone, instead of actually getting stone. Right, so we'll be using cobblestone for all of our crafting because we don't really use stone, normal regular stone for crafting pickaxes, swords and stuff for our stone tools. So if we wanted to create a shovel, what we do is put one stick and then two cobblestone, actually put two sticks and then put one cobblestone instead of a normal stone. Right. Now let's create new classes for the ores in our game, just as we did for birch leaf and stone, such that they drop, custom items. For example, we want the coal ore to not drop a coal ore, but we want it to drop a coal, and an iron ore to drop an iron ingot, a gold ore to drop a gold ingot, and a diamond ore to drop a diamond. Because those are what we actually use for the crafting recipes in our game. For example, here we need to put in a diamond to actually create a diamond shovel. Okay, so you guys know how to make this. So we're simply going to create a new class for each one of these blocks and then set an item dropped for it. And we'll set the item dropped to that specific ore. So first let's do it for the coal ore. So coal ore block dot dot. So this is the format that we'll be following. So the name of the block and then underscore block, right? And then we'll create the class coal ore block, and this will extend from block component to get all of our methods and properties. Now we need to, take in all of the properties from our constructor. So we have to require, okay, so the block component requires the block index and the chunk index. Since block component is super, we'll do super dot block index and required super dot chunk index. Then, right now we have, said that it's a coal ore block, but there's nothing programmatically defining it. So inside of the super constructor, we're going to define the block as blocks dot coal ore, blocks dot coal ore, right? And that's it. So this will give us, the same thing as just a block component. Okay, so let's just go inside blocks dot dot inside resources, and inside the get parent for block, we'll add another case blocks dot coal. If it's a coal, we're going to return the new class that we just created. So coal or block, right? So now let's go inside of our main game and then give ourselves a coal ore so that we wouldn't have to mine for it. Let's actually give ourselves all of the ores. So blocks dot coal ore blocks. Actually, let's delete all of this and duplicate the line with the blocks keyword down. So now we just need to change this. So iron ore, gold ore, and gold ore, diamond ore, and yeah, I guess that's about it. Okay, so take that away. Let's hot restart our game. Okay, so our game has loaded, and right, we have all of the ores. So let's actually modify this up a little bit. We do not need all of the shovels, but we're going to change it to pickaxes. So actually we just need one diamond pickaxe. So let's take all of these away and then make this a diamond pickaxe. Right, now let's already start a game again. Okay, cool. So now if we place down a coal ore and then mine it, we shouldn't get anything new because we didn't set an item drop for it specifically. So we just did this to make sure that we actually get a coal ore that actually functions. So now let's go up to a coal ore block inside the onload. Let's create the onload, override, and this will be a future. It'll return nothing, so void onload and then async. We also need to call super.onload for everything to work. And here we'll set the item drop to blocks or items dot coal. Right, so this is it. And now let's actually copy all of this and we'll paste this in for our new classes. So we'll create a new file for the iron ore. So iron ore block dot. Let's paste all of this in. And then we will change all occurrences of coal to iron. So we just selected, no, we just pressed Control F. We typed in coal, so it selected all of the occurrences. And then we clicked on this icon. And then we are typing in iron. And if we click on here, it changed all occurrences of that to iron. And here we can just change it to item dot iron ingot. Right, so when we mine an iron ore block, we want an iron ingot to drop. Because that is actually what we use in our crafting, grid to actually create iron tools. Right, and let's do this again for maybe diamond first. So diamond ore block dot. Let's paste all of this in, and then we will change all occurrences of coal to diamond. Yep, so oops, not dimog. So right now we've made a mistake. So let's actually just Control Z this and diamond. Right, let's replace all of this and cool. So that's it. Now finally for our gold ore. So gold ore block dot. Let's paste this in and then oops. Okay, so I accidentally copied something else. So let's copy all of this again. And let's paste this in here. And we'll change all occurrences of gold to gold. Right, and we want a gold ingot to drop when we mine a gold ore. Right, and now let's go inside of our, okay, actually let's save everything. And now let's go inside of our blocks.dot into the get parent for block. Yeah, here we'll add it, we'll add all the implement all the new classes that we just created. So for blocks.iron, don't just create a block component for it, but create an iron ore block class or an instance of that we just created. And now for diamond, blocks.diamond ore, we're gonna return the diamond O block. Right, now for the gold ore, we're gonna return the gold ore block. Gold ore block. So these are all of the classes that we just created with these specific item drops. So now let's see if all of this works. Alright, so changes have been made and the game has loaded. Now let's place this gold block and let's mine it. Cool, we get a coal ore, this one. And now let's try it for the iron. Right, that is the iron ingot. Now the gold. Cool, we get the gold ingot. And finally the diamond. And we get a diamond. Cool. Now let's finally add a parallax sky. The parallax effect is where the objects further to you will move slower than the ones near you. Implementing a sky that uses this makes the game look more realistic and 3D. Implementing this in Flame is really easy. We'll use the load parallax component function inside of our main game and then just pass in the paths to our images as the parallax image data. This returns a parallax component, which will be a collection of all of the images which we can add to our game. But we're not exactly done yet. Currently, this just displays all of our sky's images put together statically with no parallax effect. The first step to making this dynamically moving is to add the base velocity property to our load parallax component method. This accepts a vector 2 where the x will be the left and right speed and the y will be the up and down speed. We only care about the x for now and we'll set it to some kind of value. So now all of our parallax images are moving at the exact same speed. Now to make the images move at a different speed, we'll set a property called velocity multiplier delta. This again takes in a vector 2 and will define the value by how much the images will decrease speed one after the other. And we'll finally link this to our player movement. Okay, so these are the images that we'll be using for our sky. So we'll have three different types of skies. So the night sky, the morning sky, and the evening sky. So this is the base image of the night sky. Basically the image that will be at the most bottom. So the image that will move at the slowest speed compared to the other images. And this is the sky for the morning. And this for the evening. And just like our base skies, we have other two images for each one of our sky types. So we have a second parallax.png. So this is the image that will be on top of sky. And we also have that for morning and evening like this. And this. And again on top of that will be the first parallax.png. So this will move at the fastest speed, and the second parallax will move at a slower speed, and the sky.png will move at and again a slower speed. So this is the first parallax.png for the night, so the closest one to the player. Then for the morning, this is the first parallax, and then for the evening, it's this one. Right, cool. So now let's add a night parallax into our game, or you guys can do it for any of the skies that you want, but for now I'm gonna just do it for the night one because I really like it. And okay, so we'll be adding this inside of our main game. So let's go up there and on the onload here. So here we're gonna first define the actual parallax component. To create a parallax component, we'll use a method called load parallax. Actually, we have to import it first. So we're going to get that from our parallax component file. So what this is going to do is it's the load parallax component method or function will return a parallax component, which we can then add into our game. So let's call this sky, and we're going to do something here. And we're just going to add it to our game. So add sky, right? So oops, not parallax component sky equals add sky. And here we're going to actually load the parallax component. So now we have access to the load parallax component function. And this takes in a list, the list of all of the images. So the order will be from the bottommost image to the topmost image. So we'll start from our sky, then the second parallax, then the first parallax. So let's actually copy the relative path of this. Copy relative path. And okay, so this one actually accepts a list of parallax data. And we can't just provide in the path here. So we're gonna have to actually give our images for the load parallax component. We can do parallax data, and we'll pass in the path here. Let's fix up the slashes, and yep, we can remove the assets / images. And one thing, the load parallax component is actually a future, so we'll have to await it. Right, so Yeah. And this is actually parallax image data and not parallax data. So yeah, so this is actually how we load an image for our load parallax component function. So this is the equivalent of, just passing in an image like flame.images.load or something, but it's specified for the load parallax component for all of the functions that it might need. We don't know what's going on underneath. So below the sky, we'll add in our second parallax.png. So we'll replace sky with second parallax. And then on top of that, we need the first parallax.png. And if you forgot to duplicate a line down, you hold Shift Alt and then the down arrow key. Right. And yeah, so this is everything done. Let's hot restart our game. And cool. So we have our sky. Right, so we have our actual sky.png at the bottom. And then on top of that, the second parallax.png, which is the darker thing right here. And then on top of that again, our first parallax.png. Now let's make it move. To make it move, we can use a property of this called base velocity. And we can just set the base velocity to, let's say, 20 for now. The base velocity takes in a vector 2, and this will have two values, the x and the y. So if I put 20 here, it would mean, change the x-axis by 20 pixels or something like that. And if I put like 10 here, it'll be change the y-axis by 10 pixels. So, like that. But we don't really want it to move in the y-axis, so we'll set the y speed to 0. Now let's restart our game. And yeah, so our entire parallax component is moving to the left. Now to make it go to the right, we can just make this a negative value. So now it is moving to the right. So when we are moving to the left, we'd want this to actually move to the right. Okay. And currently, this is just statically moving, or I mean, it's just like an image that is moving to the left or right. Right? And there's no parallax effect going on here. For an actual parallax effect to, take place, the image behind this first parallax image, our second parallax image, should be moving at a slower rate, and then the sky should be moving at an even slower rate. Then only it'll be a parallax effect. So to actually do that, we can make use of the velocity multiplier delta property. This takes in a vector 2. And for the x, let's just place in 3 and let's see what happens. This would mean, every time it jumps into another image, it's going to multiply the base velocity by whatever the x is, right? Let's restart a game. And everything is going super fast. But we have a parallax effect going on here. So why is everything going super fast? Because we've set the base velocity to be negative 20. And then when it goes to the second parallax, it's going to multiply its speed by the x of the velocity multiplied delta. So 3. So it's going to be negative 60 and then so on. So that's why it's that fast. So we'll set it to something like super small, like negative 2 or 1, so that now everything will be at a slower rate. Let's see. And yeah, this is much better. So yeah, this already looks good. When the player is moving, it's like our entire background is changing. And let's change this to +2 or something. Or, we can just, +2 is the same as 2. And now it's going to the left. Right. Now let's, see if it works for our other skies. So let's put a cursor right to the night, and let's hold Control Alt and then the down arrow key twice. So we have multiple cursors. We'll take out night and then change it to morning. Let's restart our game. So now we have the morning parallax sky loaded. And these are the images from our morning folder. And now let's do the same thing for evening to see if that works too. let's hold Shift Alt and then the down arrow key twice. And we'll change this to evening. Let's auto restart our game again. And okay, that's working too. Cool. Now let's actually, this is actually a component, right? So we'll, create a whole new file for this, just like for all of our components. And we'll create some kind of class and then we'll put it inside there. And then we'll just add like our new class, like parallax component or something like that. So let's create a new file for this inside components. We'll call that sky component dot. And inside here we'll have a class called sky component, and it'll extend from parallax component. So let's do that. Extends parallax component. Right, so now we can just set some value inside parallax component so that we can actually, add it to our game. So right now we'll just do sky component and we can add it to our game. So before that, this is kind of empty. There's nothing inside the sky component. So if we hot restart our game right now, we should see nothing because we didn't add, exactly add a sky or anything. So we got an error, parallax not equals null. That means that inside of our new sky component, we are inheriting from parallax component. And just like the sprite property for a simple normal sprite component, we need to provide in something called parallax for a parallax component. So we'll first go inside the onload of this. So let's create the onload, future void, onload, asynchronous. It's called super.onload, right? And here we're going to set something called parallax to actually be, our actual parallax, right? That we just had. And this is the equivalent of a sprite in a sprite component. So let's set this to something. And this is, we have already done this inside of our main game. So let's go there and copy all of this code that we created for the sprite component. Actually we'll cut it because we don't really need that there. And we'll paste it inside here. Cool. And let's call this like morning sky or something. So let's import parallax image data. Right? And then here we can just set it to morning sky. But we get an error. We cannot exactly do this because this is a type of parallax component. And our entire class, what we're going to be returning in our entire class is basically what this is. We cannot so what we want to do is this, this parallax accepts a parallax and not a parallax component. To actually get the parallax out of our parallax component that we just defined, we're going to use the parallax property. So dot parallax. So now we can actually set it to this. And before running, we have one more issue to solve. So the method load parallax component isn't defined for the type sky component. And that is because load parallax component is only a function that we can use inside of the main game. So, we had it up here and it worked perfectly fine because it was inside of the main game. But we cannot exactly do that here. So, inside of our sky component, because this is not the main game. So to access a function inside of main game, what can we do? Of course, we'll use a global game reference. So let's do global game reference dot instance dot game reference. Then we can do dot load parallax component. So this is just like as we are inside of the main game, right? So we have access to the load parallax component function, right? And now this should be working. So what happened? We created a new class called sky component that we extended from parallax component. So, we're extending from parallax component to actually get all of the functions and methods of a parallax component. And then we're going inside the onload of it because every component has an onload. And then we are creating an instance of parallax component called morning sky. And this is currently the evening sky because all of the images are pointing to the evening. So let's change that to morning. Let's hold shift control alt and the down arrow key, and then let's change this to morning. Okay, and we are adding a parallax, which is the equivalent of a sprite to a parallax component, to our morning sky dot parallax, right? And we're adding that to our main game. So let's already start a game. And cool. So now we have the same thing happening, except that we created a new extra, new file for this actual component. And the entire reason why we did this is so that in the future we'll be able to link this to a player, right? And now let's make an different parallax components for our different skies. So let's duplicate this down. So let's select this and hold shift alt and then the down arrow key. We'll change this from morning sky to evening sky, and then we'll change morning here to evening because that is the only difference between all of our parallax components. So let's change this from morning to evening, control alt, down arrow key twice, and then slash evening, right? And then again for night. So let's copy all of this. Select all of this, then shift alt, down arrow key, night sky, and we'll change this from evening to night. So control alt, down arrow key twice, and then night. So right now we can put evening sky or night sky or whatever programmatically based on what the time is. So let's try with evening sky for now, just to test if this works. And it does. So we've got our evening sky, and let's change this to night sky and see if that works. And it does. So we'll eventually have a timer in our game, like a day-night timer. So if that timer goes off, if we are currently in the morning, we'll change it from morning to evening. So inside the void update of this, we'll set it so that if it is evening, we'll set the parallax to be evening sky dot parallax. And if the timer says switch to night time, it's night time now, we're gonna change the parallax to night sky dot parallax, and so on. Now let's actually control the movement of our parallax sky component. So we'll set a property called component motion state, and if it is component motion states dot idle, we don't want the sky component to be moving. If it is walking left, we want the sky to be moving to the left, and if it is walking right, we want the sky to be moving to the right. We'll eventually link this to our player movement. Okay, so let's first define the component motion state property for our sky component, which we'll use to move it in different ways. Alright, so just gonna do component motion state and component motion state, and we're gonna default it to component motion state dot idle. So we'll make it so that when the component motion state is component motion state dot idle, the sky wouldn't move at all. Like right now it's moving to the left, but when the component motion state is idle, we don't want it to move at all, like this. Right. And when the component motion state is 2, or when the component motion state is not 2, when it is like component motion state dot, let's say, walking left, we want it to be we'll set the base velocity dot x to some kind of a positive value, like here we have done 2, so that it'll go to the left like this. And when the component motion state is component motion state dot walking right, we'll set the base velocity to a negative value so that it would go to the right, like this. So let's do that. And in the beginning, we wanted to be component motion state dot idle. So let's just default it to this for now. And we'll default the base velocity of everything to 0. So, whatever sky we choose, like if the night, even if it's a night sky, evening sky, or the morning sky, it initially won't have any velocity at all. So what we're going to do is we're going to check if the component motion state is idle. If yes, we'll set the base velocity dot x to 0, which means that the sky won't move. And then we'll check if the component motion state is component motion state dot walking left. If it is walking left, we're going to set it to some positive value, the base velocity dot x. Like, we had two which made our sky go to the left. And then if it is component motion state dot right, we'll set the base velocity dot x to some negative value. So, we want this to happen, every time or every frame of our app, right? So, when the player okay, we'll make it so that the component motion state of the parallax sky changes every time the player moves. For example, if the player is walking to the left, we also want the component motion state of the sky to be walking left. If the component motion state of the player is walking right, we'll set the component motion state of the sky to also be walking right. Same with idle. So, these checks are being done in every frame of the app. So we'll define this logic inside the void update, double gt, and super.update. Right. And so we'll check if the component motion state, the component motion state is component motion state. And what all are the component motion states that we're using? So idle. If it is idle, so now we need some kind of way to reference the actual sky. And we can do that with parallax. So we have set the parallax to the actual parallax component, right? So we can access that here. Parallax. And we can also do parallax dot base velocity. So now we can also access the base velocity. So it's super easy now. And now we can set the x speed to something. So if it is idle, we don't want the sky to move at all. So we'll set the x as 0. So, nothing's changing. And parallax is actually nullable because it is a property that we can either put in a parallax component or not. That's why it's nullable. So we actually have to put an exclamation or a null check for it. And we'll have an else if, or let's just duplicate this down. Let's hold shift alt, then the down arrow key. Now, if the component state is walking left, we want the sky to be moving to the left. And to move it to the left, we'll just set it to some kind of value like 2. Let's duplicate this down again. Shift alt, then the down arrow key. And if it is walking right, we want the sky to be going to the right. And if it should be going to the right, we'll set the x to a negative value. Right. So right now our component motion state is idle. So if we hot restart our game, the sky shouldn't be moving at all. And it's not cool. Now if we set it to component motion state dot walking right, it should be going to the right. And it is. Now let's do component motion state dot walking left. Now it should be going to the left. Right, cool. Now let's actually link our sky movements to our player movement. For example, if the player is walking to the left, we want the sky to move to the right. And if the player is walking to the right, we want the sky to move to the left to give us the sort of moving effect. Okay, so if we are detecting the player movements, we obviously have to go inside of the player component. So let's go here. And then let's go into our movement logic function. So here is where we are actually detecting, where the controller is pressed and when to move the player. So here we have if the player should be walking left, right, or idle. So it's simple here, right? So if the player is moving to the left, we want the sky to move to the opposite direction. So we'll just set the component motion state of our sky component to walking right inside of here. But how do we exactly access our sky component? So let's go inside main game first. And here we're just adding an instance of sky component here, right? So let's do the exact same thing that we did for a player component by, we'll assign a variable to this. So we'll create a variable called sky component, and we'll just create an instance of that sky component, and we'll add that instead of directly just adding in an instance of this sky component. So this means that, with our global game reference, we'll be able to access everything inside of main game, and we'd have access to the sky component. And then to change the component motion state of a sky component, we can just do dot component motion state and then set it to whatever we like. Right, cool. So now let's go inside of the main game, actually not a main game, our player component. And here let's access the global game reference. So global game reference dot instance dot game reference, then world data. So now we're inside of the actually not world data. We can do sky component. So when we're doing dot game reference, it's like we're inside of main game, and then we can access the dot sky component. So if the player is moving to the left or walking left, we want the sky to be going to the right. So we'll set it to sky component, the component motion state of the sky component, to component motion state dot walking right. And let's copy this. And if the player is moving to the right, we want the component motion state or of the sky to be going to the left, so walking left, so in the opposite direction. And when the player is resting, we want the component motion state to be idle. So it's, that is it. It's that simple. Let's auto restart again. Okay, so as expected, the player is not moving, so the sky isn't either. Now let's move to the left, and the sky is moving to the right. And if we stop, the sky also stops. And now if we move to the right, the sky moves to the left. Cool. But we have one small issue. Now, when we are colliding with a block and still pressing the right control button, the sky still thinks that the player is moving and hence moves the sky. That is because, let's go here. And, when it says moving right inside of the movement logic, that moving right means that the controller is telling the player to move right. But that doesn't account for if the player is actually moving right. So, we're checking if the player data.component motion state is walking left. The component motion state tells the player what it should be doing, right? It doesn't exactly tell us what it is doing. Like, for example, we're setting the component motion state to right if we are pressing the right control button, and it to left when we are pressing the left control button, regardless of what the player is actually doing. So we want some kind of way to know if the player is actually colliding somewhere. So let's actually go inside of the move function here, and let's change the void to a bool. So we'll return true or false, and then here we'll return true if the player has successfully moved to the right or the left or the direction that the player has specified. So here, we're checking for each case, like, the case that we actually taken in as a parameter. So if the player should be walking left, we are setting the component motion state of walking left here. And if it should be walking right, we're setting the component motion state of walking right here. So inside this, we have a statement actually checking if the player is colliding. And only if it is not colliding, it's actually moving, right? So inside here, it means that the player has successfully moved because it is not colliding to the left and it has successfully actually moved. So we'll return true. So true, when we return it here, would mean that the player has moved, right? And outside of here, we'll remove the break and then return false. So this would mean that the player has not successfully moved to the left. So return false. Because this if statement did not satisfy, because it went inside here, not colliding left. If it was not colliding left, it would do all of this and then return true. If we are returning true once, it will just ignore the rest of the code and just return true, right? But if this condition did not satisfy, it's going to go outside and then return false. So this is a great way of knowing if the player has actually moved. And we'll return true here, just as we did again, and then return false. And let's not do a break. We'll just return false, because why not? And that's it. Now let's go inside of our play component. And now we can put the move inside of an if statement, because it returns bool, or a type of bool. So we'll do if this, meaning what does this statement actually mean? It's actually first going to move the player, and if the player successfully moves, meaning that there was no obstacle in its way, it's going to return true. But if we do this while the player is colliding to the right, it's going to return false. So the player is not actually moving. So we'll only set the component motion state of our sky to component motion state dot walking right if the player has successfully moved to the left. And let's do the same thing here. We'll put this inside an if. If it has successfully moved to the right, then set the actual component motion state of the sky to be moving to the left. Right, so this should have fixed it. Let's see. Okay, so everything's working fine. When we move to the left, the sky is going to the right. When we move to the right, the sky is going to the left. Cool. So now let's try colliding with something. So let's go up to the right a little bit and now to the left. But it still does not exactly work. Let's see. Okay, so this is because we're only setting the component motion state of the sky to be idle when the player is not moving, right? But the game actually thinks that the player is moving when we hold down the left key. So even though we did not successfully move, and it's not exactly moving the sky component, what's happening is that it's not setting the sky component from moving right to idle. That is what's happening. So inside here, this if statement actually works. So to fix this, it's really easy. We'll just put an else. So if it has not successfully moved, we'll set the component motion state to idle. And same here, let's copy this else statement and then put it here. So this should have fixed it. Now let's try colliding with something to the left. And yeah, so now the sky does not exactly move when we are colliding to the left. So again, what happened was that once we hold this at the beginning, or whenever we hold the left button, it's setting the component motion state of the player to be walking left, right? And in our logic, we were successfully doing that if the player did not move successfully to the left, we wouldn't move the sky. So here, we're checking if the player successfully moved. Only then we'll set it to walking left. But it was, we didn't change it from walking left to idle when the player collided. So we simply put an else statement to do that. Yeah, that's it. So now let's create a custom timer called Sky Timer, which will fire every 1/3 of the game's total daytime. The daytime is the time from morning to night. So every time this timer fires, we'll change the actual sky from, let's say this is night right now. So when the timer fires, we'll change it from night to morning and then so on. Okay, so we'll create this inside of our resources. So here we'll create a new file called, let's call this sky timer dot. And this will be a class, and let's just call it class sky timer. And this will be specific to a world. For example, in one world, you could be, at the morning. In another world, you could be at the evening. And in another, you could be at the night. So that is exactly why we are creating a new timer class for this, so that when we actually save our world and then quit our world, the time will still stay intact. So you'll eventually understand why we're doing it this way when we actually implement world saving. But for now, let's just create a new property inside Sky Timer called Sky Timer Seconds, and we will default this to 0. So if the world has, if you join the world and 1 minute has passed, the Sky Timer seconds should be like 60.0. So, it'll be in seconds. So how do we actually do this? We can easily do this with our main game, or anything inside of dt. So inside of our update we have a parameter called dt. So dt is a frames per second. So when the game is at, let's say, 10 fps, the dt will be 0.1 or something. So we want our actual Sky Timer seconds inside of our timer here to be 1 second. Where's the timer? Yeah, here to be 1 second when 1 second in the game has passed. So in a void update method, we'll just add the Sky Timer seconds to dt. So each frame, we have 10 frames per second. That's what 10 fps means, right? So if it's 10 fps, the dt will be 0.1. So in 1 second, we have 10 frames. So it's just going to add 0.1 to Sky Timer seconds 10 times. And what's that going to do? It's going to take our Sky Timer seconds up to 1. So 1 second has passed. So what we're going to do is, at each frame of our app, we're just going to add Sky Timer seconds to dt. So we'll do that with a function called update timer, and this will take in our dt, and we'll simply do Sky Timer seconds plus equals to dt. It's that easy. And now let's, we need to update this. So let's go inside here. And then, okay, so the Sky Timer will be specific to a world. So that means we'll be adding it to our world data. And as we know, world data is the actual class or the instance that will be used to create specific worlds, right? So here, down here, we'll just create another instance just like this. So Sky Timer equals Sky Timer. Cool. And now let's go inside of our main game again into the void update. Here we can now access the Sky Timer instance inside of world data, because we just added it inside world data. World data dot Sky Timer, and now we can use the update timer function and then pass in dt. And let's just print the actual time. So let's see if it actually works. And let's do, okay, so we to print the time, we'll do world data dot Sky Timer dot Sky Timer seconds. Right, let's auto restart our game. And now inside the debug console. So 1, 2, 3, 4. Yeah, so that's, a really well working timer. So again, what are we doing? We're just adding our Sky Timer seconds, which starts at 0, to dt. So dt is the fps. So let's do this with another example. So if the fps is 20 fps, that means there will be, the void update function will be called 20 times in 1 second. So that is, our frames are updating 20 times per second. So the dt will be 0.05 or 1 by 20. So when we are adding, okay, let's say at the beginning we have a value called, val equals 0. And at each frame, if we are adding the dt to our val, we'll do this 20 times. So in 1 second, what will happen? This will get to 1, right? So this will happen 20 times in 1 second. So that will take the val up to 1. So that is how we are actually calculating the time. So now let's go inside constants and then actually define the time we want one day to be. So one day will be, you guys know what a day is, from morning to evening to evening to morning again. So that period of time will be the day in our game. So let's go inside of a constant, because this will be a constant, it will never change. So this will be an integer. We'll define this as seconds. The constant integer daytime or total time in a day. For now, we'll set it to something like 10 so that we can actually, or let's set it to maybe like 15 so that we can, debug this better. Eventually, we'll change this to something like 5 minutes or something, so like 300 seconds or whatever. But for now, let's keep it as 15. So through this 15 seconds, we want our, sky time to change from morning to evening to night, right? So in the first 5 seconds, it'll be the morning. So 0 to 5 seconds, it'll be the morning. Then 5 to 10 seconds, it'll be the evening. And then 10 to the other 15, it'll be night. So our sky time is updating 1/3 of the total time in a day. So 5 seconds. So 5 seconds is 1/3 of 15, right? So let's actually go inside of our sky timer again. And let's actually create a new enum called sky time. So enum sky time. And this will be just our, sky time. So morning, evening, and night. That's it. And now here, we will check if the total time has passed 1/3 of our daytime. I'll tell you what that exactly means real quick. But here we'll do if sky timer seconds greater than or equal to then our total time in a day. So total time in a day divided by 3. If yes, we're going to print update time. So let's see what the issue is exactly. The name sky timer is already defined. Okay, so we'll change to sky timer enum something. Okay, let's hot restart our game. And let's go inside here. So okay, that's hot reloaded. And 1, 2, 3, 4, 5. So at the fifth, at the beginning of the 5th second, it said update time. So this is exactly what we want. We want our sky to update every 5th second or whatever 1/3 of our total time in a day is. And as you see here, it's keeping on printing update time after this. So we'll just set the sky timer seconds to 0 again. Sky timer seconds to 0. So it starts from 0 again, and then it'll go up to 5 seconds. So let's see now again inside debug console. Okay, it's just printing 0. Oops, I meant to do this inside of a if statement here. Oops, let's change this to be inside of here, and let's restart our game. Okay, 0, 1, 2, 3, 4, and 5. Then it said update time. Then it's starting from 0 again. Update time. So just after 4 seconds, it said update time, and so on. Right, so that is working. So just like our sky timer seconds, let's create a new property. This will be the property that we'll use throughout our app to actually know what the time is. So this will be of type sky timer enum that we just created, and we'll call this sky time, and we'll start it off at morning. So sky timer enum dot morning. So what we want to do every time this happens. So this happens every 1/3 of our total time in a day. So every time this fires, what we want to do is, if the current sky time is morning, we wanted to change it to evening. If it is evening, we wanted to change it to night. If it is night, we want to change it back to morning, and so on. So let's add the logic for that. So we'll first check if the sky time is sky timer enum dot morning, and this is sky time. So if it is a morning, if it is currently the morning and the timer has fired, meaning we want to switch it to another time, and the time after morning is the evening, right? So sky timer enum dot evening. I mean, it's not really evening, it's noon, but in our game we'll just have it as this, and then let's just duplicate this down with an else actually. So let's copy this and paste it down. And now for the same, if it is evening, change it to night, else, and then we'll paste this again. And if it is night, then change it to morning. So we'll put a print statement now here at the end of this and say sky time is now, and we'll put a $sign and then print the actual value of sky time. Right, let's not restart our game. So, okay, that's actually printing. We don't want that to happen. So let's actually go to our main game and then into our void update. Here, let's remove this print statement and hot restart our game. So every 5 seconds, our function should be firing. So our game has started, and any time now it should print sky timer is now sky timer enum dot morning, and it fired it again now 3 times. Okay, so that is not exactly what we wanted. So let's check what we did wrong. Let's go inside sky timer again. Here we have morning, evening, night. Okay. Oh, okay. We're not setting the value of sky time to actually the new value. My bad. So sky time equals sky time dot evening. Sky time equals that. Sky time equals, oops, that, and it's not sky timer. Cool. Let's see if that works again. Let's auto restart our game, and let's go into our debug console. And yeah, so it was morning at first, and now it changed to evening, and now it's night, and now again after 5 seconds, or 1/3 of our total daytime, it's morning, and then it'll do this in a loop. Now it's evening. Right, cool. So now we have an accurate way of knowing what time the game should be in. Now, why did we actually do it this way? Why couldn't we have just created another timer component for it? So if we had created a timer component, we wouldn't be able to exactly save the current time. So that is why we're doing it like this. So let's go over what we just did. So we created a property called sky timer seconds, which is defaulted to 0, and that is added to our DT each frame of our app to accurately give the seconds that has passed since the creation of our game or whatever. And then we're checking if the sky timer seconds has reached 1/3 of our total time in a day, and if yes, we need to actually do some functions, our updating functions. So inside here, we created another property called sky time, and we set it to morning in the first. So inside of this, which fires every this fires every 1/3 of the game's total time or total daytime. So every 1/3 of the total game time with switching, if it's the morning, we're switching to evening. If it's the evening, we're switching to night. And if it's night, we're switching to morning. Right, and then we're setting sky timer seconds to 0 so that this logic actually works. And we'll actually use the sky timer enum to change the sky. So we'll change it from night to morning, then morning to evening, and so on. Now let's actually make the parallax sky change according to the sky timer updations, like this. Okay, so there's two ways of doing it. One inside of a parallax sky component here. So inside of the onload, or not the onload, inside of the update, we could check what sky time it is, and then accordingly we could change the parallax to be the corresponding sky to that specific sky time, right? But that would be happening each frame of our app. We don't want to make actually a game, so we don't want to waste all of that processing power for something that will only happen at like a small a period of time, so like every 1/3 of the game's total time, right? So a better way of doing it would be directly inside of a sky timer. So here, and okay, so when we want to change from morning to evening, we'll set the sky time to evening. And the whole reason why we have a sky time is that we'll be using this at different places, just rather than just in a sky. So that is why we have a dedicated variable for this. So here we're gonna change the actual parallax of our sky component to be the evening sky, right? So let's do that. To access our actual sky, we're gonna do global game reference dot instance dot game reference, then parallax sky, or dot sky component, that is the actual sky component, and then we'll set the parallax property. So this parallax property is the same thing inside of here, this one, and we'll set this to like evening sky or something. So let's go inside sky timer again, and this equals to, let's copy this and paste this in here, sky component dot evening. Okay, sky component dot. Okay, now to actually access the evening sky, we we need to have it inside of a global environment. For example, inside of our sky component right now, we have defined the night sky, evening sky, morning sky, all inside of onload, which is a function, right? Think about it this way. Let's say we had a function called sum or something, and then inside here we had a variable integer total or something like as 5 or whatever, and we wouldn't be able to access the total inside of here because it is a local variable inside of this function. So to make it global, we can do something along this. We'll initialize it outside of our function or inside of the class, just as we are doing for component motion state, which we can access from outside somewhere. So we'll do morning sky, and we'll set this to late initialization. That means it'll be initialized at some point in time. We're telling the static analyzer check to stop worrying about this. I will definitely initialize this at some point in time. Okay, and we just that's what the late does, and we can remove the parallax component here. So what we're doing is we created an instance here, or we initialized the parallax component here, and then we're actually initializing or putting a value to it inside of our onload. So now we can access it outside or anywhere within our sky component, right? So late. Okay, let's rather than doing that, let's copy this entire thing and paste it in here, and this will be late, this too, and let's paste this in here. This will also be late. And now these are already initialized, not initialized. We've defined the data type, so we don't need to do parallax component morning sky equals. So we're just assigning a value to that. Now inside of sky timer, we can do dot sky component and then access our evening sky, morning sky, night sky, because it is inside of a global kind of scope. So we wanted to change it to evening sky when this fires, right? And then what's the problem? Okay, we need to do evening sky. So evening sky is a parallax component and not a parallax. So we'll do dot parallax. Right, now let's copy this. And when it's evening, we'll change the sky time to night and also change the actual parallax to night sky. And then here, when it's night, we're gonna change it to morning and then change it to the morning sky. So morning sky dot parallax. Right, so that is it. Let's already start our game. Okay, we start at night. Then, okay, we change it to evening. Right, that's correct. Now to night again. After this, we should go to the morning. Yep. And we actually want to start at the morning. So let's go inside of a parallax component. Here. And we'll actually we're not going to set it to anything for now. So now let's try that again. But we should get an error. Right, because we didn't actually initiate, we didn't give a value to parallax, which cannot, should not be null. It can be null, but it should not be null. So, as I said, the sky timer will be something specific to a world, and then we'll be saving this and then reading this from a hard disk or something. So the sky timer will not always, always start as a morning, because let's say we were at the night time and then the player decided to close the app or the game and then open it again. So we want to start back at night time. So, we need to initialize the parallax just as we did a few moments before we actually just deleted this. And, rather than just randomly giving it a value like this, we need to give this value based on based on the current sky time. So we'll just put a case inside of here, or a switch statement for the sky time. So to access the sky time, we'll do global game reference dot instance dot game reference dot world data dot sky timer, then the sky time, and we'll have the cases for it. If the case is sky timer enum dot morning, if it is morning, we want the parallax to be the morning parallax. So morning sky dot parallax. Cool. And we're gonna break, because we have to do that every time for each case, or it's gonna keep on checking for the other ones. So case, now again, sky timer enum evening. If it's evening, we want to set the parallax to evening sky dot parallax. And then finally, for the sky timer of sky timer enum of night, if it's night, the parallax is going to be the night sky dot parallax. Right, and then we got a break here and here. Actually, we don't need to do it here, but whatever. So why are we exactly doing this? Because in our onload, we need to give some kind of value to parallax, but it cannot be just another value. You'd think, Adi, but we always start our game at the morning sky. Yes, but that will only be, as of now, that's the only situation that can happen. But when we add world saving, you could join a world which was at the night. So if you join, if you left a world which was at the night time and then joined it back again, and then here we had defined the parallax to be the morning sky, that would kind of break things, right? We want the night sky to display. So the actual sky time will be something that is going to be saved when a world is quit or something. So we're going to use that to actually display the correct parallax. So that is what we're doing. This will all make sense more when we actually implement the world saving, right? So now let's see if this works. Let's already start our game. Okay, so now we start at morning. And let's just assume that, or let's create an instance, okay, inside of our sky timer again. Let's just pretend that this is a data, the sky timer instance is a data that we're reading from a hard disk, and then the player had left this world at the night time. So now if we join again, so this is the situation where we're joining again, we should be at night time. Because yes, because the parallax component checks for the parallax when it's when it's loading, and it changes it according to what the actual value of sky time is. Right, so we'll put this as morning. Right, so that's working. And now finally inside of our constants, we'll change this from 15 seconds. So 15 seconds is a total daytime. We'll change it to something like 300 seconds. Right, cool. So this is like 60 on 5 times 60, or 5 minutes per day. Right,